using those models and softwares is to examine our hypothesis, right? So you need to know how to develop your hypothesis and how to establish your hypothesis, right? So in establishing your hypothesis, there is two types of error. We call it type I error and type 2 error. Usually for error in hypothesis, we have
flash.
Okay, we have here, we call it null hypothesis and alternative hypothesis. Null hypothesis is referred to the default one, which means the acceptance one. And the alternative one is the research hypothesis, which means what the researcher is claiming. You want to explain what you claim, right? So then here we have two types of error. First, reject the null hypothesis when it is true. Reject null hypothesis H0 when it is true. We call this type of error, we call it type I error. Okay? Or type 1 error. So then reject the null hypothesis when it is true, then this one type of error. And here, reject the null hypothesis when it is false, this is the right one. Okay, then the second one is we have failed to reject the null hypothesis. Failed to reject H0, or we call it null hypothesis. So failed to reject the null hypothesis when it is true, that means the right one or the correct one. The second one is fail to reject the null hypothesis when it is false. This one, the type 2 error. So this is what you have to understand from the beginning, based on what you reject and accept the null hypothesis.
Bro, can you explain with an example? It will be easy.
Like when we say the null, because we have two forms. We have the null is equal to H0. We have three forms of null hypothesis. Mu equal 0. The second one, or we call it alternative hypothesis. Mu not equal 0. Okay. This is one form. The second form is H0 mu more than 0. H1 HF mu1 more than mu2. HA will be mu1 less than mu2. Then the third form will be H0 mu1 less than mu2. Then the alternative is mu1 more than mu2. So this is the three forms of any alternative for any hypothesis. So here there is two types of error. We said we reject H0 when it is true, like you reject the reality. So then you will do error 1. Second one, you fail to reject the null hypothesis when it is false. So then we call it type 2 error. Okay, so we have three forms. And when we say null hypothesis usually is referred to the reality, not the reality, sorry, refer to the default one, or the acceptance one, or the general information. But the alternative, what the researcher is hypothesized, what he assumed, what he is claimed. So we are looking actually to test the alternative one. Okay. So this is the two type of error that is usually is existing in any hypothesis. So to test the hypothesis, we have you have to go through many steps in order to test whether null you have to accept the null or reject the null hypothesis. There is 5 steps. In the first one, you have to state the null and the alternative hypothesis, which means you have to choose one of those 3 forms, either to use form 1 or form 2 or form 3. Then the second one is determine the significant label, because you have to determine also the confidence interval of your hypothesis. When you hypothesize, you said I assume something happened with 99%, for example, or with 95%, or with 99%, right?
Yes.
So then we have to determine our confidence interval. So then we have to here determine the significant label designed by usually is 0.05 or least. Here how to find the 0.05, which means this 1%, right? It will be 1 minus, or we call it alpha. 1 minus 0.99. It will be 0.01, right?
Yes.
The second label is 1 minus 0.95, which means 0.05. Then the third label will be 1 minus 0.90, will be 0.8. So those 3 significant labels we use to examine or to test any hypothesis. Okay? Yes.
How to determine the significant level? Whether it is a 5%, 10%?
This one is based on the researcher. You can make it like, but usually in medical science, for example, they make it 99%, because you cannot accept any error. But in social science, it can be 95 and less than 95. Okay? Because in medical, if you, for example, make 95 and there is such error, then it may, when you create any products, it may cause such effect, right?
Yeah, large effect.
Yes. But here, for social science, is just numbers. For example, you hypothesize about something related to education, it will not give direct effect to the human being.
Yeah.
But this one, you need to make it with a high level of significance. Your confidence interval should be 100 or 99%. Okay, then after you determine the significant label, you have to choose the appropriate statistical test. Because we have 2 types of tests. We have t-test and z-test. When we have to use t-test, also when we have to use t-test. We use t-test when the population is known. When the population unknown, we use z-test. Okay? Sometimes you don't know the population of your study. Then you have to use z-test. If you know the population, you have to use t-test.
Can you repeat?
Here, when we select our sample size, it says I want to do study about IIiBF. Then the population of IIiBF, let's say we have 1,000 students. Then when I select my sample size, maybe I select 100. Right? So now I know my population. The population is 1,000. So then in this case I use t-test. But if let's say I don't know the population, I don't know how many students in IIiBF, then I just use z-test. This is the way to distinguish between z-test and t-test. Then after you find the z-test, you will find the result of z-test, right? So then after that you have to compare the value of the z-test with the significant label. If the value of z-test is more than the significant label, you have to reject. You have to reject the null and accept the alternative. This is the steps how to examine your hypothesis. Okay?
If the significance level is higher than the value of Z.
Yes. No, if the Z value or T value is more than the significant level, you have to reject
The null.
the null. You have to you have to you have to accept the null. We reject if it is less than the significant
Less than
level.
the
Yes. Okay, so those the 5 steps when you come to test any hypothesis. But when you do the software, you will not get any. You cannot go through all those steps. You run the t-test or regression. You will find the t-value and the significant label. Then you see if the significant label less than 0.05, you accept, right? You reject the null and accept the alternative. This is the idea. So it's clear. This is the steps we use to follow when we test any type of hypothesis. So now we will go to here. When we come to also the hypothesis, we have usually we have two types of hypotheses. We say first one we compare the mean. The second one is to test the cause and effect relationship. That's all. What we study in statistics. We have two types of hypotheses. We call it we have first one is compare mean. The second one is cause and effect. This is two type of hypotheses that is existing in the overall statistics. Either to compare A to B, we see which one is, whether they are equal or they are different, right? Or we want to examine whether there is cause and effect relationship between dependent and independent variable. This is the idea of statistics. So when we say compare the mean, like we have different type of different level of comparison. For example, I want to compare A to itself. For example, here we call it one simple t-test. Here we have testing the hypothesis on a single mean. Then the second one, testing the hypothesis with two related mean. Then testing the hypothesis about several means. Then the third one is multivariate techniques. This one used for cause and effect relationship. So here when we say compare mean, we say I want to I make the hypothesis for this class. I said what the mean of the CGP of this the student of this class is. I said 3.5. This is my assumption. So now I want to examine my hypothesis, whether what I assume is correct or not correct. So here I have only one population and I have one symbol mean. So then I want to examine this mean. Now what I have to do, I compare the mean to each student, right? So then we will do, we will come to test like when we have one population mean and when we have two population mean. Here when we say testing hypothesis about two related mean. Two related mean like the same population but I test it in different time. Let's say I give you the exam before we get this workshop. Then I record your scores or your marks. Then after the workshop I give you the same exam. Then I see how your answers, right?
Yes.
Then I record your marks. Then I compare before and after. This type of test we call it related mean. Okay, like you compare before and after. Then because you want to see the effect of this workshop, how the student, whether their level is improved or not improved. Okay? Then the third one, testing the hypothesis about several means. Let's say I want to compare the performance of this class with another two class in different kulliyah, for example. So then here we have different mean. Then I want to see whether all the students in each, let's say in each faculty, they have the same level of understanding in statistics. Then I gave the example, for example, to IIiBF student. Same exam I gave it to engineering student. Then the same exam I gave to the Sharia student. Then I want to see whether all students they have the same level of understanding or not. So here we call it variance or several mean. Then the third one, when we use cause and effect relationship, I want to see whether variable A has a relationship with B or not. Then we use here, for this one we use one simple t-test, here we use two simple t-tests, then here we use ANOVA. ANOVA, yes. For cause and effect relationship, we use regression. We are going to through all these type of tests. So now we go to test. We use the first one simple t-test. When we have only one population mean or one symbol. Okay, you know what mean population? Here we say this is the population and symbol is the back of the population, because you cannot examine or you cannot make test for the whole population. It will be time consuming. You need to take the symbol from the population and you select this symbol randomly. Then you can generalize based on, you can generalize the result of the symbol for the whole population. Okay, in statistics we cannot use the whole population. We just take the symbol, then we generalize the result for the whole population. Because when we select this symbol, we select it randomly. Okay? So now we test when we have one sample size. So we go to the software. You have here this file. You can open you have a SPSS here, right? You open SPSS in your this one. Try to open the SPSS in your computer. Then we use this file here. We have so this is the SPSS. This is the file. Here we have to monitor. We have here variable view and data view. When we when you want to use the SPSS, first you have to open the variable view. Then you key the name of the variables here. Okay? You key the name of the variables here. Then you select the type of the variables, whether it is matrix or non-matrix. Then you hit the weight, whether you make how many decimal, like you want 10 or 5 or 2 or best what you want. And then here the label, you have to write the name of the variables, the full name. Then here you write the values. This one we use it when we have like Likert scales, or we have nominal or categorical variables. Like you need to keep the, for example here gender. You will write the gender. We will come to all these things. Just give you such idea here, but when we come to the practical, we will. So here for missing, if you have missing values, then the most important here is the measurement. Here you have to keep the measurement. You have usually we have 3 measurements. Please say here. Let me just. Can you open this file? Microsoft Excel. Here we have one symbol. Okay. You select this file. So let's say this is your CGB. This is your CGB. Here we have, let's say, 13 students in this class, and this is your CGB. So you just write here the name of the variables. Let's say CGBA. Okay. So now type of the variables is numerical. Okay. Then weight, keep it 8. This may make it 2. So label here, just you can write the full name of the variables. Right? Then value here, you don't need to change anything because this variable is numerical, it's not categorical or nominal or not scales. Because we have, you remember in scales, we have from 1 to 5, right? Yes. When we use Likert scales in the survey, we have from 1, 2, 3, 4, 5. 1 refer to strong disagree. Then 2 is disagree. 3 is natural. Then 4 is agree. 5 refer to strongly agree. Okay. So when we have Likert scales, then what you will do here, you will keep the value here. You will just make, for example, 1. Then you write strongly. Strongly is agree. Right? Then you make add. Then 2 refer to disagree. Return value levels. Yeah, you go to the value, click on, then you will find this window, then you just key the information. Then you make here agree. Here you make 2. So you make 1 here. In the label, write the name of the variable. Like here, the variables is, we said is Likert scales. You have to write the Likert scales.
Value should be 1 or 2. Value 1?
1. So okay, level, but for this data, the one we are going to use now, we are not going to use this information. Just I told you what you have to do with the value. Here you can add any information that's related to or describe your variables. For the current one, which is going to use, we are going to use here, it's not the variable is numerical. There is no, it's not categorical, and it's not also nominal, and it's not legal scale. It is just continuous numerical variables. Okay, so this one we use it when we have survey, for example. Then you have to describe the data of your variables because it is legal scale from 1 to 5. Then the system can supposed to read it. It's not, this one is not continuous numbers, right? This one refer to strongly disagree, and this one refer to other things. So, I mean, this one only we use. We will come to this one. Okay, we will come to it later. Just keep it without doing anything. Okay. So here we're saying you don't need. The most important is the measurement here. When it is numerical data, just select scale. When it is categorical data, you use ordinal. When the data is nominal, you have to use, you have to select this one, nominal. Nominal like male, female, the demographic information about the respondent. Ordinal, when you have, the data is like, you have to select based on your preference. Let's say, I ask you one question in the survey, I said, which university you prefer? Then you will give such university, or let's say I give you 10 universities, then I told you to choose or to arrange them based on your preference. Which one is the best one? Maybe you will select UIA is the number 1, right? Then let's say number 2. But other student will select number 1. Then when you have like this type of question, you have to select ordinal. Okay? But when it comes to demographics, variables, you select nominal. Because nominal is not considered as a metric data. It's non-metric data. Okay? So here you select scales. So now what you will do, this is the variable name. We already key all the information for this variable, right? Yeah. Now we go to another window, this one, data view. You click on data view, then you key the information here for the CGB. Here, for example, I just copy it from here like this. Copy, right? Then you go to here, make paste. Okay? Everybody done these steps?
Yeah.
Not yet. Okay, just very simple. You go to Excel, you copy from here, then you paste it in the data view window. This is the data view, then you just press here, then you make paste. Then the data will appear, right? So now my hypothesis is what? So what your hypothesis here? How much the CGB of this class should be? How much your CGB? This says the CGB is, we assume it is 3.5, right? This is my assumption. As a researcher, my assumption is the CGP of this class is 3.5. So now I have to write the 5 steps of testing the hypothesis. First, we said what? In the first step, what we have to do? See here. State the null and the alternative, right? So what I will do here, null, H0, we call it null. We said mu equal the mean. This one refers to the mean. the mean of this class equal 3.5.
This is now.
Yes. So alternative mu is not equal, right? This is the idea.
So the alternate.
Sorry, here. Alternative I will see. Some they wrote here 0, they must be here 1. Same also. Okay, you can make A or 1. So now I want to test. This is my state, state, the null, and the alternative. Then the second step is determine the level of significance. I said I assume the CGB of this class is 3.5 with 95% confidence interval. So that means my alpha, how much it will be? Because alpha is 1 minus the confidence interval. My confidence interval is 0.95, right? Then it will be 0.05. This is my significant level, or we call it determine the significant level. Then choose the appropriate statistics. Here, the population is known, right? In my data, you see here the population. How many students we have?
13.
We have 13 students. So my population is known. Then I have to use t-test. The t-test is the x bar minus mu. Mu is the mean of the population, the one I assume. Divide the standard deviation of the sample size, divide n, the total population, or the total population.
But means let's say expert means total means of the.
No, this is the mean of the sample size. Minus the mean of the population, divide the standard deviation of the sample size, and divide the root square of the number of the population, the number of population. Okay. So then I will get the value here. So this value I have to get, because you have to use t-test, because each value you go to the t-test because this one in terms of t, then you have to find the equivalent significant level for each value. Okay? Let's say here we found one figure, then if you see here, this one 0.05.
Yeah.
The significant level for t should be 1.96.
Yeah.
significance level.
Yes, because here the t here should be 1.96 to be equal with this figure. So then you have to use t-test. I will show you how to use the t-test. This one, t-test table, okay? This is the t-test table with different significant level. See here, 1, 2, 5, 10, 20. In our studies, we said it will be 5%.
It is table 210 or 110?
This one,
210?
this one I think 110. You have to check there is another one here, 210 or 110. Here. I think this one. Okay, let's say we use this one first. This one, the Z test, has Z table, okay? But for T, it will check here. You just do this, but with one tile or two tile. Okay, let's say here, let's assume this table is for one tile. Okay? So now what you will do, you will find the figure of T here, then you go to the T table to find the significant label. And then you compare the significant label of T test with the significant label that you determine earlier. Okay? Then you make decision. If the significant label of Z test is than the significant label that you determined earlier, then you have to reject the null and accept the alternative. Okay? Let's say here, see how much the T test have from the, you just do analyze, go for compare mean, then we select one sample T test. Why we select one sample T test? Because only we have one sample size, right? We have only one class. We have only one population mean. When we have two population mean, that means we have two sample size. We compare the sample size of population A with the sample size with the population B. Then we see whether there is a difference or not. But here I want to compare the sample size for one sample size, but compare each student to the mean. That's I assume, like I assume here the CGB of the student is 3.5, right? But to which degree my assumption is correct, right? I have to examine it. Now see, you click on one sample T test. Then this is the variables here. The one I have here. It's already here, right? So I move the variables from this window to test variable window. You click here, then. So now the variables already here, right?
Yeah.
Here I have to make
Test values 1.
the mean that I assume. Then I compare the CGB of the student with the CGB of the population mean that I assume by myself. Okay? So here you wrote how much?
3.5.
3.5. Now you click OK. See here, this is what the option to determine the significant label. The confidence interval that you want to establish your hypothesis based on. Here, the confidence interval is I can change up to me. I can make it 99. I can make it 100. It's up to you, right?
Minimum 90.
Yeah, but usually in social science we use 95. To keep it 95. Then continue. Then OK. Now see, this is the result. Here the information you have. N is 13 students, right? This is the number of students in the class, or we call it the population, the population of our study.
Yeah.
This is the mean. This is the CGB, the mean of the student CGB. But I assume how much? 3.5. So this is the standard deviation. which is represent this one.
Yeah. Yes.
Standard deviation we was looking for, right?
Yeah.
And also this one is the standard error mean. This is the difference between, we call it between y and the expected y. This one we will come to it later, okay? Don't worry about it now. Now we have to look for the t value. This one, the t value is minus here, the one who was looking for. It's already given to us. If you see here, your x, how much? 2 point here. 2.96, right?
615.
15. Minus the deviation mean is
3.5.
3.5. Divide the standard deviation is
0.75 778.
0.75
778.
778.
Yeah.
Okay, then divide 13.
13 root over.
Then you will get the t test, the t value, which is here. This one. It will be negative
Minus 2.5.
2.562.
562.
So now this value I cannot compare it directly with the significant label, right?
Yeah.
I have to find the significant label of this t value. Then how to find this? I go to the t test, the t table. So for the t table first, I have to know how much the degree of freedom. Degree of freedom, because you cannot use the table directly. You have to check the degree of freedom. It will be k minus 1. K is the number of the students.
Yeah.
Minus 1. So it will be here, how many students we have? 13, right?
13, yeah.
Minus 1, it will be 12.
12.
Then I go to the row number 12. Then I go to the significant label, because the table is like this, right? Here you have degree of freedom. Here we have the significant label. Then what I will do, I go to here number 12. Then I go to the significant label 0.05. Then I will find the significant label of this value. Okay? Then after that, I compare the significant label with the significant label that I determined before. If I found the significant label is this done the significant the significant label I determined early, then I reject null hypothesis and accept the alternative. Okay? This is the way how we test our hypothesis. See now, it's already given here. You don't when you use SPSS, you don't need to go for T table. T table if you don't know if you don't have the software. But here you have the software already given to you. How much the significant label? 0.02, right?
Yeah.
So then the significant label here, the t test, the significant label of t test, it will be 0.025, right?
5, yeah.
Now I have to compare the significant label with the significant label I determined early, right? Say here how much the my alpha with is more than
0.05.
the t significant label, right?
Yeah.
Because alpha here how much? It will be 0.05,
5.
which is more than
0.05.
0.025, right? So now I have to make decision whether to accept or reject the null hypothesis. Now based on this one, I have to accept or reject. We said we reject the null hypothesis if the t value significant label is less than the alpha or the significant label that I determined early.
Accept.
So now we reject.
Reject.
We said we reject if the t value significant label is than is less than the alpha that we determined early. So now we reject the null hypothesis, we accept the alternative, which mean what? Which mean the mean of the student is not 3.5. It is 2.9. You didn't get it, right? Okay, we go to the steps again here.
So we should reject the, we should accept the null, reject the alternative, because I claim the CGP is 3.5, but it's not true, right?
Yes, that's why we reject. It should be equal. We reject, we accept this one, which means not equal. Okay? See here, first steps is state the null and the alternative. This is my first step. This is my first step, okay? The second step is determine the significant label. Okay, my significant label here, 2. Significant label will be alpha equal, it will be 0.05. This is my significant label, which means 1 minus 95. Then the third step is what?
Statistical test.
Find, I have to determine which t-test I have to use, right? We said if the population noun, we have to use t-test. If the population unknown, we use z-test. Here, our population is noun, right? Which is 13 students. So then I have to use t-test. This is the third step. T equal x bar minus new population mean divided standard deviation divide the root square of population. Right? So this one, the result was how much? 2 point from the software.
Which is the?
Here it was the population 2.5. 2.2, right? Minus 3.5. Divided standard deviation 0.7. 7, right?
7.577.
Huh? Here.
Mean
The value was minus.
296. 296.
7.5.
Mean is 2.9615.
Huh?
X bar equals 29.
9615.
2.9.
Upper one.
2.9. 2.9615. Right? Then how much the result? T how much?
A minus
This
2.9.
one, T here already
Minus
given here.
2.5.
It will be negative 2.562,
5.662.
right? Then the significant label now. If you want to draw this one, what you will do? You can just draw like this. This is the distribution of, here is the mean, population mean. So now, this is the data distribution of this example. Here the significant label is, we said 0.05 here. Okay, this one is 1.965. 1.965, which means here 0.05. 0.05, because this is our interval. We said it is 1.6. You know why I said 1.695?
Yeah.
This one equivalent. You remember when I said 0.05? When I go to the t-test, the value is 1.965. Okay. So this one, this area. This one we call it accepted area, acceptance. This one is rejected area. Here. the rejected area. Okay? This one is the accepted, this is the rejected. Now I have to see the t-test. This is the 2.562. Where is existing? It's existing
Rejected area.
here or out?
Out.
Out. So that means is in rejected area.
Yeah.
So that means I reject the null and I accept the alternative.
Alternative.
Clear?
Yes.
Yeah.
If you cannot understand this one, you have just to compare. I told you, very simple. You compare this value with the significant label. If this one less than 0.05, we reject the null and accept the alternative the same way. Here just I try to show you why we reject and why we accept. Because the value of t is out of the acceptance area, is in rejecting area. Clear?
Yeah.
So now the third step, we said we find the t value, then we find this is the value, and the significant label of this value we got it from TT ball or we got it from the software, which is 0.025. Now to make decision, number 4, step number 4, make decision. So what's your decision now based on this result? Reject or accept? The null. Null, we said new is
Reject the null.
Now reject.
we reject the null and accept the alternative.
Alternative.
Now we make decision. Reject null and accept
Reject the null.
Alternative.
the alternative.
Accept the alternative.
Which means the CGP of the student, it is not 3.5. This one, right? Not equal to 3.5. So this is the way how to use the t test for one symbol mean. This one clear?
Yes.
So that's very simple. You don't need to do all these steps. The software already do the calculation for you. What you will just focus on, the t, the significant label of here, with the significant label you determine. Then you compare. If this one less than the significant label you determine early, then you reject the null and accept the alternative. And what is the alternative? Alternative is what the researcher is claim or what the researcher is assume. Clear? Yes.
What means to take?
Come again.
This is to take. What means?
To tell this one, the distribution of the data from both sides, right and left side. We call it two take. When the distribution only in one side, we call it one take. Yes. The distribution of the data. Because here, the two take, it will be like here, in the left side and the right side. Distribution of the data. Yes. Yes. Because sometimes the distribution in one side of the data. So now it's clear?
Yeah.
Okay, now we'll go for the second step. Second, testing the hypothesis here with the two unrelated.
Unrelated or related should be.
Say with related.
Yes.
Here, pair symbol t-test. This one we use it when two related mean. Two related mean. Now let me assume what? I want to compare the CGP of the student in this bar and the CGP of the student of the second bar. Or, not like this. I want to compare correlated, like I give you a test before the workshop. I give you a test to see your ability or your performance or your understanding of statistics. I give you one test before the workshop, right? Then after the workshop, I give you the same test. Then I compare your result before and after. And this one, they use it in for example, those who work in usually in education, or you try to compare the performance, or you want to evaluate the performance before and after training, or okay?
Yes.
Because you want to see whether the training is the training
This
is
is the performance evaluation. Performance
Yes.
evaluation.
yes, performance evaluation or anything. You want to like compare before and after, like before crisis, after crisis, before. I mean, you have to compare two population related mean. Okay, related mean. You cannot compare two unrelated mean. So now we have two type of tests. We have to use the t-test with matrix data. For non-matrix data, or let's say when we run the normality distribution of this data, we found the data is not normal distributed. Then we cannot use t-test anymore. We have to use Wilson test. If your data is not normal distribution, then you have to use Wilson test. Or if your data is non-parametric data, or we call it non-matrix data, then you have to use non-matrix data, like for example, you have nominal variables, or you have categorical variables. This type of data is not, it is not parametric data, it's non-parametric data. Then you have to use Wilson test. Okay? But for this workshop, all our data is matrix data. Then we are going to use the t-test. Okay? So for t-test with the two pairs or two related mean, we have to use here. This is the example. We have here the score of for first week, then the score for last week, or the score before the workshop and the score after the workshop. Then I want to compare with the. So now what you will hypothesize here? You will do the same steps. You will do the same steps what we have done before. You will, because all the hypotheses based on those 5 steps. The first one, you need to establish your null and alternative. The second one, determine the significant label. Then you have to use z-test or Wilson test. Because we said if the data is non-parametric, you have to use Wilson test. If the data is parametric, you have to use t-test. So for this one, we have mu1 equal mu2. Like the population of, the mean of population A equal the population of
The mean of the population.
Then the alternative is 1 not equal 2. Right? So then the significant label is say 0.05. Now I have to use t-test. The t-test here you have to use x bar 1 minus x bar 2. All minus mu1 minus mu2. Then divide standard deviation.
Square root.
Then here divide
Divided by square root of n.
n1. Sorry, here it will be s divided n1 plus s divided n2. Okay, this is the formula. Then you will find the result here. Then after that, this is the third step. Then you have to find the significant level of this t. Then make the decision whether you accept or reject after you compare. All the t-test is, all the statistics is established based on t-test, or if the data is parametric, use t-test, and all the hypotheses testing is go through all those 5 steps or 4 steps. Okay?
Yes.
So now we go for this one. We test it using the software. So you go to your data. Now you delete these variables here. Just delete it. But before you delete here, you go to this one. You click here on the right side of your mouse, then make clear.
Yes.
Okay? So we go to variable. view, then you write the name of the first variable. So what's the name of the first variable? Score of first week, right?
Yes.
So you write here score for, just make first week. Okay? Then score for second week. So first week. Score for second week. Okay? So now I have wrote already here the name of the variables. I go to data view, then I go to my data, just I copy from here, from 1 to 10. Don't copy the average, okay? Then make copy. You paste it here. You go to the second one. Then clear. So now what you will do, you need to test. You just say analyze. First you need to clean those three, because you have before 13, right? You clean from 11 until 13, make it like this. Already here I don't have, but for you, you have, I think. You need to clean it. Anyway, so analyze. You go for compare mean. Now you select from here pair symbol t-test. So now you move the variable from this window to here, variable 1. Then you select this one to the variable 2. Right? So now you have here variable 1, variable 2. So what you will do now, for the option, just give it 95. Okay? Then continue, then okay. Now this is the result. This is the mean of the first group. This is the mean of the second group. Number of observation or number of scores. Students, we have 10. The standard deviation for each group. Then the standard error for each group. Here, the summary. Right? This is the correlation between group A and group B. This is the significant level. Here, the most important is one for me, because I'm looking for t-test. Right? You see here, this is the t-test, this is the significant level. Significant level, no value. Oh, here. Significant level is 0.01, right?
190.
You see here, yes, 0.01, right? 9. So now you will do also the same. If you come to the steps, you will do the same. But now, because I told you, just take it very simple way. You look to the significant level, compare it with the significant level that you determine with your confidence interval. Here is 0.019, which is less than 0.05. So now we reject null hypothesis. We accept the alternative. So which means there is no difference. They are equal. We reject the null, then we accept the alternative, which means they are not equal, right? And this truth, they are not equal. See? The mean is 57 and the second one is 70, which is the correct one, right? Which means the mean, because first we assume they are equal, right? We assume that they are equal. Now we assume the alternative, they are not equal. So when I did the test, I found this one is significant, which means I reject the null and accept the alternative, which means the the score of the student in the first week is different than the score of the student in the second week. But to see whether the performance is better or not better, you have to look for the mean. This mean is 57, but now the score is become 70. So that means there is improvement. The training that's given to the student in the first week is get a good result for their performance. Yes. Oh, that's what I told you. You have to delete. There is one variable there. I know there is one variable. Okay? This one clear? Everybody understand this, how to test the two population mean? So this is the way how to do it. If we use Wilson test, let's say when we run at the beginning, we run the, you have to check the normality of the data distribution. If you find the data is not normal, then you cannot use t-test because your data is become non-parametric. You have to use Wilson test. Also Wilson test will compare the same. Will give you the significant label, then you make decision, accept or reject. But we use Wilson test when the data is non-parametric, which means the data is not normal distributed. Because if the data not normal distributed, you cannot use the t-test as well as you cannot use regression, normal regression. You have to use logistic regression. We will come to this one, okay? But here, because we assume like the data is normal distributed, then we use t-test. If we test, we find the data is not normal, then we go and we use Wilson test. And Wilson test is here, the same. I mean, there is no any issue. You just go analyze. You go for here, non-parametric. Then you go for, you select here.
That's prof. Initially, how would I know that it is parametric or non-parametric?
Based on the normality distribution. You have to make tests. Because usually when we do any analysis, first we have to examine the assumption of the data. There is 4 assumptions. First is normality, linearity, multicollinearity, and there is 4 assumptions.
Hetero.
Yes, that assumption should be achieved in the data. If the assumption is not there, then you consider your data is non-parametric. Then you use the alternative model. You cannot use t-test. You have to use Wilson test, or there is many type of tests. See here, for example, when I said analyze, compare mean, here see how many tests we have. One simple t-test, independent t-test, summary, independent simple t-test, then BERT simple t-test, and then ANOVA. If your data non-parametric, which means the distribution of the data is not normally, then you have to use non-parametric. See here, you go down, then here. The same test there is there. The same test. You will find the same result. But when you come here to open this one, there is the different name. We call it Wilson test instead of t-test. But the same label of category of the mean, because we have like one simple mean, we have 2 simple mean, we have 2 independent simple mean, and then we have several mean. When we have several mean, we use there ANOVA. Here also we have another test. Okay?
Non-parametric test.
You go for analyze, you go for non-parametric.
Then
you use one simple test, independent simple t-test, related simple test. Then you go for, also here you have many also. You didn't find there, you can just check this one. Then you can choose the one is related to your. Okay? So now until now it's clear?
Yeah.
Okay, see here now we go for our BERT simple t-test, then test hypothesis with unrelated mean. Unrelated mean, before, you know, when we said related mean, like I test the performance of the same student before and after. But when unrelated, we say I make test for the student in IIiBF and the same test I give it to student in education, for example. So they are unrelated mean, right? So then I want to compare, like, or let's say I want to compare the performance of UIA with the performance of a UM student. So that's mean unrelated mean. Okay, then for unrelated mean we have to use the t-test also, but they have different tests here. Analyze, because unrelated tests mean they have like categorical, two group. Let's say I want to make the exam for the student male and female. This one we call it unrelated. Then you have to use the group here. See, for example, here you go to general compare mean, then you select independent symbol test. When we said independent mean unrelated. So you click unrelated here. But for this data, we don't have here the unrelated. You can open another file. I'll show you here. You close all these things. You go to. You can close this one also. Don't need it. You go to this one, workshop. Now I want to, let's say, examine the here. This is the variables. In these variables, we have 5 factors. The determinants of job satisfaction, for example, we have here supervisions, we have the payment, justice, and promotion. All those variables affect the job satisfaction. So if I want to compare the job satisfaction in terms of male and female in any organization, so this means what? We have two independent symbol, right? So what you will do, you will go here, analyze, compare mean, then you select independent symbol t-test. Then I select, this is the variable, let's say job satisfaction, I put it here. Then I go to the group, here, grouping variables. You click on here, gender, I put it here. This is now the gender. Now I go to define groups. Define groups. In the data already, one refer to male. I just put here, one male, two is female. Right? Then I make continue. Then I make okay. So now this is the number of male in my study is 189. The number of female is 69. The mean of male is 3.9. For female is 3.95. So now I want to compare whether when you come to state your null hypothesis, you said what? Male and female have the same level of job satisfaction. Okay? Your assumption or your hypothesis, male and female, they have same level of job satisfaction. So now I want to, my assumption is what? They are different. Okay? My assumption is, or the alternative or the researcher assumption they are different. Male, they have different level of job satisfaction from female. Then you state your null and the alternative hypothesis. Then you determine also the significant level. Then you use z-test or t-test. Then you find the value of t-test and the significant level of t-test. Compare it with the previous significant level. Then you make decision whether to accept or reject. The same steps. If you see here, you go to this one. This is the t-test here. This is the t-test. And this one is the significant level. So here, when the significant level is more than 0.05, So in this issue, we cannot reject the null hypothesis.
Yeah.
I cannot reject the null hypothesis. So that means what? Male and female, they have the same level of job satisfaction. So this is the idea, how to test two different or unrelated population mean. So it's clear? The same steps.
The researcher claim was job satisfaction is different.
Because you usually every time the null hypothesis, which is the default one, like the normal situation is supposed there is no difference.
Okay.
But I am as a researcher, I said no, there is a difference. When I have female in my company, their level of satisfaction better than the level of man. This is my assumption. Okay, then I have to test my assumption whether it's correct or not. Then I have to go through all those steps. Okay. So now it's clear.
Yes.
Yeah.
What is different this living test?
Come again.
The difference between this one and this one. There are two significant values.
Equal balance.
Which one? This one.
Living test. This not it? No.
Oh, F.
Yeah, the other side.
No, no. Use t-test. This is the t-test, and this is the significance level. This one is more than 0.05, which means more than my significant level that I determined earlier. So that means I cannot reject the null. I have to accept the null, which means there is no, they are equal. Okay? So now clear? Okay, we go to the second step. Let's say now we compare here two population mean, right? 1, 2. Let's say we have more than 2.
Several.
We have several. We have 3 population mean. We have 4. Then here we cannot use t-test anymore, because t-test only to compare 2 population mean. Here you have to use ANOVA. ANOVA means analysis of variance. Okay? Analysis of variance mean. You have to use ANOVA. So now for ANOVA, let's say here, you go analyze, compare mean, then you select ANOVA here.
But here we have only 2 variables. So how?
Where?
In this data.
Yeah, that's why I will use different variable. I will use different variable. Let's say here, see, you go to the data here,
Yeah.
the categorical data. Let's say the female, sorry, what is it? The education, for example. Education here, this is the value, right? For education. See how many category we have? 6 categories. Right? So that means I have 6 population mean. Right? So now I want to compare whether there is a difference between the level of education, like there is a difference between diploma and bachelor, master, PhD and others in terms of job satisfaction. Okay? Or in terms of supervision. Or so then when we have different population mean, then I have to use ANOVA when we have more than 2. If we have 1, I use 1 symbol test. If I have 2, then I have to use 2 symbol test. Sorry, I use t-test with 2 symbol mean. And when we have 2 also, we have to see whether they are related or unrelated. Then if we have more than 2, then we have to use ANOVA. Okay? There is also ANOVA, there is MANOVA, and there is MANCOVA. There is 3. Yes. Because based on the dependent and independent variables. Sometimes the independent is categorical. Then you can use ANOVA. But until now, because as the basic,
Yeah.
we just go with ANOVA. Because there is many. Yes. So, okay. Now we use this one because we have 6 category, right? Then I have to use ANOVA, analyze, compare mean. So we go for compare mean, we use one way ANOVA.
One way.
Yes. So now my dependent variable, we said what? We say job satisfaction, right? Here. The category I use here, for example, the education level. Right? Then I go to here, post hoc. Then I select 2P. You select 2P.
2P.
Yes. I have given you here in the slide how to do the steps.
So job satisfaction is dependent and factor is
Come again?
job satisfaction, that is dependent list.
So check here. Okay, here you need to select also, then make continue, then you go for here. So this one option. For option. For option you have to select the first one and the second one no and the others. Just select first one and the homogeneity, brown, instead, then college, then mean. Then continue, then okay. So now see the result.
So can you repeat, sir?
Which one? The test.
The analyze from the analyze. Analyze, compare,
Education. Yes.
analyze, compare
Okay, we
mean.
do it again.
Yeah.
Analyze, compare mean.
Okay.
Then you go for ANOVA.
ANOVA.
Yes. Everybody reach to this point?
Yeah.
Okay. Now you go from here.
Job satisfaction.
You should take job satisfaction.
The
Move it
dependent
from
list.
this window to the dependent list window.
Yeah.
Then you go for
Options.
post hoc. You select 2P. 2P. And the significant label keep it 2.05. Okay? Yes, 2P only.
Only.
Then you go for option, you select the first one, descriptive, homogeneity, brown, then village, then means, blood, then continue, then okay. So this is the result now. This is the descriptive of the variables. Then you go to the most important here. Here we have to use F test. Okay, we are not going to use T test. With ANOVA we use F test. And this is the significant label. This one is not significant. So that means what? If you see the null hypothesis for this one, the null hypothesis means all are equal. The six category, they have same level of satisfaction. So this means mu1 equal mu2 equal mu3 equal mu4 5 mu6. Right? This is my null hypothesis. My alternative, at least one is different. At least one is different. This say I make equal mu2, then not equal mu3 equal mu4 equal mu5 equal mu6. So the idea is what? At least one is different. Okay? This is my null and this is my alternative. Okay? So the same. I determine the significant label. Then also I use here Z test. Sorry, I use F test. F test. Okay? Then I compare the result of F test, the significant label, with this significant label. Then I make decision whether they are equal or not equal. So if they are not equal, then maybe I found, let's say I found A and 2 is equal. But I need to find which one is not equal. then I have to go for, there is two tables here. First table is show me the overall. Overall, they found what? It's not. There is no difference. It's not significant, right? So that means I cannot reject the null hypothesis. When it's not significant, I cannot reject the null hypothesis, which means they are equal, right? Here they are equal, right? Because the significant label is more than my significant label. So that means I cannot reject the null hypothesis. I reject only if this one less than the significant, my significant label. Okay?
Yes, sir.
So in this issue, we cannot reject the null hypothesis, which means they are equal. But in case, for example, in case they are, this one is significant, you have to look for the second table. This one. This one, it gives you the t-test. What is it? Here, the significant label, sorry. We put the significant label here. Based on each one. Non-qualification with diploma, bachelor, master, PhD, and others. See, the significant label, all of them not significant. All of them not significant. So if we found there is one significant, you will find also the F test is also significant. Okay, but because the global F test, when we found the significant label, we found it's more than the significant label that we determined, right, early. So that means they are equal. And this one is confirmed here. But if there is a significant, let me give you another example here. We'll try with analyze the compare mean one way. Instead of education, we just take A, for example. Here also no significant. Let me try select another variable. Analyze. Operation. Sorry, compare mean. One over. Let me take this one out. Then I select by me. Then insert edge. Education. So I say. This one also not significant. This what we have to do. So anyway, I mean you have to understand the rule of thumb. If the global F test is significant, then there is a difference, which means we reject the null. But here, because the global F test is not significant, we cannot reject the null, which means they are equal. There is no difference between the education level in terms of job satisfaction. Okay? Now, until now, you still in the class? Huh? Your mind is still in the class? Yes.
But before starting the analysis, we have to make sure that our data is already clean.
Yeah, of course.
Yeah. So
Yeah.
how to identify the missing data?
We will come, we will come. But now just we try to teach you the basic things. Then when we come to the data analysis, that's when we will run based on testing. Okay?
Yes, sir.
Now we go to the second. What is that? Yes. So you remember at the beginning of the class we said we have two types of hypotheses. We have either compare mean or regression, right? Cause and effect. Now we go for cause and effect relationship. This one, like if you want to compare only. But if you want to study the cause and effect relationship, you have to use regression. You are not going to use the compare mean test. For regression now, we have also two types of regression. We have simple regression, we have multiple regression. Okay? For simple regression, when we call it simple regression, when we have only one dependent and one independent. Okay, simple regression. Take rest. Yeah, sure. Okay, we'll take rest 10 minutes, then we'll continue. So you take your breakfast.
management in Dubai by 2017. And I just Dubai, Sharjah, Al-Ain, Abu Dhabi. But each there are small
outside, you can have yourself. So you
okay? So this is the idea of statistics. For example, if you take the book, you read by yourself, then this is the constant. Then if I give you workshop, then the level of understanding will increase, right? So this is the slope of the effect of the workshop, for example, X. Then how much the workshop can influence your level of understanding. So this is the idea of dependent and independent variables. So now we go to examine the cause and effect hypothesis based on or using the regression analysis, or we call it simple or multiple regression, based on the model. How many variables in the model? If we have one variable, independent variables, we call it simple. If we have more than independent variables, we call it multiple regression. Okay? So now we go to, but see here, before we go to, before we test the cause and effect relationship, you have to study all the assumptions of your data. That's why one of the students, he asked me in the previous section about the normality and right. You are the one who asked me. Yeah, now we will come to this one. Okay. So before you run the regression analysis, you have to go through all those steps. In the first steps, you have to learn how to key the data in your software, right? Sorry, in the SPSS. This is, you see here, you say, you remember here we give you this file, right? Here, workshop file. But before you open this one, just I show you here how to key the data in, because we are going to step by step here. This is the steps, okay?
Yes.
We just follow those steps, then you will learn how to use SPSS from the beginning. So you go to SPSS, you open the file. Everybody open SPSS. Now let me just try to key the data. Let's say here, my data is job satisfaction. Just write job satisfaction like this. The name of the variable. Okay. Then type of the variables. You just select numerical. Every time just keep, because the default is numerical. Okay? Wait, just keep it as a default, A. Then decimal will be 2. Label here, you can write the full name of the variable. Like write like this. Job. Right? Now I wrote the full name. Job satisfaction. So for value, the second column, you click on the value, then you will find this window. So when I come to my data, when I came to evaluate the data, we have here 5 Likert scales. From 1, 2, 3, 4, 5. So 1 refer to strongly disagree. Then disagree, then natural, agree, strongly agree. This is how to arrange your Likert scale. Some they do 7, some they do 9. Okay, it's up to you. But I mean, this is the basic. I mean, the normal one. We say here, we say strongly disagree, right? Disagree. Here, just we wrote disagree, right?
Yeah.
Here, natural, right?
Yeah. Agree.
Natural. Here,
Agree.
agree.
Strongly.
This one,
Strongly.
strongly agree. Okay? So that's, now we need to key this information here. So we write 1, you type here 1. 1 is, the label of 1 is what? Strongly disagree. Strongly disagree, right? then add. You click add. It's already here, right? Because you know the software is not going to. Usually, software is using numbers, but you have to define those numbers. 1 is refer to what? 2 refer to what? This is the idea. Like we define the data in the software, because the software, when you deal with the human being, when you give them the survey, they will read, agree, disagree, then they mark, right? But the computer cannot read, agree, and disagree. Computer will read the numbers, but we have to define what 1 is referred to what. Strongly agree how the software should read it. They read it in terms of numbers, then they use the mean to evaluate. So 2 disagree, right? Then add. 3 natural, right?
Not.
4 agree. 5 wrongly agree, right? So everybody key this information. You have key all the information.
Yes, sir.
Yeah.
So after you finish this one, you just make OK. So now if you click again here, you see the information already there. So for missing here, you don't need to do anything. You keep it empty. This one, keep it. Then you have to go to this one. This is the most important. The measurement, because you have to measure your variables. Because we have 3 measurements. We have scale, we have nominal, we have ordinal in SPSS. Scale used with continuous variables, numbers. Like for example, when the normal data, like scales from 1 to 5, this one is called continuous data. But if the data is categorical, like as I told you in last section,
CIIBF.
when we said we want to, we have like we give the respondent to choose give us their preference for something. Like you prefer this university or the another university. So this type of information is not numerical. It is categorical. It's categorical. Like you give the university that you like the previous stage, then the second stage. This one is not represent numerical data. Then the nominal, like I want to describe the respondent of the characteristics of the respondent, whether they are male, female, whether they are educated or non-educated, their demographic location, all these things. So that's one we call it nominal. So you go to this one, you click here, you select. If your data is continuous data, then you use scale. If the data is, as I told you, based on the preference of the respondent, use ordinal. If it is demographic information, you use nominal. Okay? So for this one, is Likert scales, right? You should use scale. Then we make okay.
You can use ordinal also.
Where? Here, no. This one cannot use ordinal. This one is Likert scales from 1 to 5. Ordinal, when the question itself gave the answer is based on like category. I gave this university category number 1. I gave the another university category number 2. So this one we call it categorical data. Okay, but this one is scales data. So just select scales. If let's say here, the second variable is gender. Right? Then I go to here. I wrote just gender again. Then you go to the value. See here, value you give 1 to man. Sorry, men. 2 gave it for female. Right? So now make okay. Now to go to the measurement. How to measure these variables? This variable is nominal.
This is nominal.
Nominal. Then I select nominal.
Gender,
Clear?
male or female,
Come again?
value in certain line,
Okay. Oh, you go to value.
value in certain line, okay.
Here, you just write 1 male, 2 female, you add.
One,
See, for example, I remove this here. Then I do it again, sorry. I remove, then here. 1 male,
two,
add. 2 female. Then add. Then I say okay.
okay, good.
So you go to measurement. Here, measure, you select nominal. So now it's clear?
Yeah.
This is the way how to key your variables information. Then now we need to learn how to key the data, because this is only the variables information. To key the data, you go to data view. So you go to the data view here. If you see the job satisfaction here, we have 5 skills. When I ask the previous respondent, he say strongly disagree. Then what I wrote here, I just type strongly disagree. I type 1. Then the system will read it as like strongly disagree. Just make 1. This say the one who respond to me is female. Then I type 2. Right?
Yes.
If you want to make this one in a word sheet, you just make like this. It will appear as a word. If you make it as a number, just click on this. But when you key the information, key all is numbers. But this one, if you want to read it as word.
Yes.
So now you learn how to key your data, right? So now you close this one. You close this file. You don't need anymore because we have already one file ready. This one. I have already done it for you. You just use it. Here the name of the variables, and this one is the data. But here every time when you start key your data in the software, you have to create ID for respondent. Because when you collect the respondent, let's say you collect 300, then you write ID for each respondent from 1 to 300. Then here also you have to key ID number for respondent number 1. Then this is his answer. Okay, this is the way. So now our idea is what? To do the regression. To do the regression analysis. But before we run the regression analysis, we said there is such assumption in the data should be achieved. Otherwise, the estimation coefficient of this relationship or the slope will not be correctly estimated. Then you need to first you need to make data screening. We call it data screening. And then you see if there is any missing data. After missing data, you have to check the outliers, because if there is outliers, the data, your data will be not normally distributed. Then you cannot use regression. Because you use the regression with non-normal distributed. Use normal regression, it will be the estimation coefficient will be biased. Then you have to use logistic regression instead of normal regression. But here we have to go through all those assumptions one by one. Then we learn how to do all those tests. If you see here, we said first key the data. We learn how to key the data, right? The second step, find and report missing data. Also, you need to know how to find the missing data, because some respondents, when they fill the survey, they forget to keep such information. So you cannot add the information by yourself, because if you add such information by yourself, the data will consider as artificial, because you create it by yourself. It's not represent the perception of the others. Then you have to keep it as it is. But you have to know how, you have to summarize the missing data, and then you have to check if the missing data is less than 5%. You can replace with the mean. If it is more than 5%, you have to keep it as it is. If it is less than 5, you have to replace with the mean.
The mean.
Yes, because if it is more than 5 and replace with the mean, that means the data will be artificial data. It will not reflect the reality or the perception of the public. Okay? So the first one is find and report the missing data. To find and missing to find the missing data, you have to go for analyze, descriptive, then you go for frequency. So then I key all the items. This is my data until education. Okay? Tell education, okay? Then say you move them to the second, the variable window. You move them from here to here. This one I don't need it now, because this is my respondent from the survey, right? This is number of items, because this one we call it items. Like each variables is measured by many items, right? So this one we call it the items. I think I have here. I will show you what's mean items and what is. See this one. This one we call it items. Item 1, 2, 3, 4, 5. Because the items is measuring, let's say those 5 items measuring one construct or one variable. So when you key the data, you key it based on the items. And this is the Likert scale. Right? So like here, for example, in our data, if you see supervision, this is the model, our model here, it will be in our model here, we have job satisfaction as a dependent variable. Then we have alpha plus beta of supervision. Then plus the beta of payment. Then the beta plus beta of supervision payment. Then justice. Okay. Justice. Then plus the beta of what else? Promotion. Then the error test. Okay, so this is our model actually there. So for supervisions, this is as a variables here. But these variables is measured by many items. Like here. This one is the items. This one items. 1, 2, 3, 4, 5, 6. Those measure only one construct, or we call it one variable, or one factors. Like here, supervisions is measured by 6. Here. See, supervision 1, supervision 2, 3, 4, 5, 6. 6 items. Those items is measuring the concept of supervision. Okay? But here, when I come to the formula, I have to take the mean. But before I go for multiple regression or before I go for regression anything, I just want to check my data. So to check the data, I have to key the items, not the factors. Okay? I have to key the item because there is maybe such missing data in one item, not in the whole factor. Okay? So what you need to do now, just say, you click here, display frequency table. Then make OK. See here what you have. This is the table for missing data. This one is the valid. The valid means the one is existing. 250 respondents. The missing data for each item. For the item 1 was 0. Item 2, 0. All 0. Then you have to report the missing data. This one you have to report it in your thesis. There is no missing data, for example, in this data. But when it comes to reality, there is missing data. Let's say now there is such missing data. Let me just delete, just to give you an example. If we say here, I delete those 3 values. I delete them, right? Now let me run again. Analyze, descriptivity, then frequency. Then I said okay. See now I have 3 missing data here. Then you have to report how many items is missing for each item. I mean how many data is missing for each item. Okay? See now this one 3%, 3 respondent divide 3 missing divide 250. Divided 247. If it is less than 0.05, we say now 3, right? 3 divided 247, right? How many percent? Can anybody do the calculator? Calculate this.
3 over?
3 divided 247.
No calculation.
One
0.012.
Point
zero
08.
008.
Yeah, 864.
8.
Yeah, 64.
64. Like this, right?
Yeah,
So
64.
this
Yeah,
one, how many percentage?
5533.
This is like 0.8%,
Yeah.
right? 0.8%. This one less than less than 5%. This one 0.8, not this is not 5%. This is less.
It's not 0, 0.
008.
It's 001.
Okay, can anybody give me again?
1.2%.
0,
1,
0, 1, 0,
0,
1, 2,
1, 2,
1.
1. Just we say 1.12. So this one times 100, how much it will be? 1.2%,
Yeah.
right? This one is 1.2%, which means is less than 5%. So in this case, I can replace with the mean. I can replace with the mean. How to find the mean? I go to these variables, then I check the mean. See here, this is, where is it, the variables? Which variable? This one, SUB1. You go to SUB1. Here, you go to analyze, descriptivity, then you take here. Descriptivity, you just select this one, SUB1 option, then I select only the mean because I am looking for the mean, this one. This one I don't need here. Then I said okay. See now, this is the mean, 3.39. So I go to this empty data, I just put this figure, 3.39. Okay? You have to take the overall mean of the respondent, not the mean of Likert scales from 1 to 5. Because some they do the mean one, they take 1, 2, 3, 4, 5. Then they take the mean of this, they sum divided 5. Then that's wrong. You have to take the mean of the respondent, the overall respondent. You have 347 respondents, and each one answer one Likert scale. You sum, divide the 370, you will find 3.39, the one we have here. So then you go and replace this figure. I go, for example, here.
But if we have too many missing data,
That's why you have to see how many missing data. Like here we have 3.
if we have too many, for example,
If it is
20,
more,
30,
if it is more, then you cannot replace. If it is more than 5%,
we delete that.
you have to delete or you have to find another data. Yes, bro. You want to ask?
If the coding of information is not the same, but we do not missing data.
What do you mean the code?
When you enter the file
Okay.
of, that will be not missing, but will be errors or like this.
No, code should be based on your Likert scales. You will see what you have.
If you put like say number another from this number,
Oh, another one.
another
So
one,
this one, it will not report the missing. That's one when we do the outliers, it will appear. Because the interval of your data from 1 to 5. If by mistake you enter 6 or enter 7, for example, you know sometimes when you keep, sometimes you keep different wrong number. So when you go for outlier, the second test, then it will show you this is outliers. Yes. Okay now? This one clear? So the missing data, you need to find first the missing data, then you need to see the percentage of missing data. If it is more than 5%, you have to keep it empty. If it is less, you have to find the mean, then replace the mean in the missing place. Yeah.
Okay, and you repeat again how to find the mean.
The mean. The mean is just from here. Analyze, descriptive, then you key the items here, then option, select from here, mean. Then continue, then okay.
So if the value is less than 5%, then keep it up at the same.
Yes, keep it empty. I mean keep it missing.
Oh, keep it missing.
Yes. Because if you replace the missing when there is a high level of missing, you replace it by the mean, like you already create different data. And it will not represent the perception of the people. It represent your own mean. Okay?
So we let it empty.
Keep it empty or you have to drop it. You drop the whole respondent of that guy. No, not drop it when you come to drop this, see here. Also when you drop this one, not only drop from these items, you drop it horizontally. You just from here to here, make clear. You will drop everything. Like you have to drop the case itself, not drop only for this item. You drop the case itself, or you drop the respondent. The survey for that guy, you just delete it from your data. For all items.
they don't affect
Of course, that is just a problem. That's why you need sometimes to keep it. Because the software, when they calculate based on also the mean. They will not calculate based on how many numbers. Yes. So now it's clear. Now we go for the second step.
How to replace it?
You replace. You just key here 3.39. Then 3.39. 3.39. So that's all. But here it's not appear because you have to change the decimal here. Where is it? Here. You can make the way decimal here, just make. Then you go to your data here. Here. See already here. Right? So now the second step is Yeah.
Are there another interface to release data? Another interface to interpret data? The other interface?
Oh, you want to enter the data? Which data? The same one.
This data. Like this data.
Same data. You want to enter it? We already here. Just you type here 3.39. Then it will be
You can enter it manually. Type
manual. This one.
Manual.
Yes. There is also, if you want to do it, you can do it by the software, but it's not available actually. There is one function here. That's why when I use my laptop, it's there, but here it's not existing. There is one function here. You just give you the report of missing, then ask the software to replace with me. Because when you print from here, the software show you. Tomorrow when I use for BLS, I will use my laptop, then I will show you this one. The software show you the report with graph and give you also the location of the missing. So then after that you just check the percentage, then ask the system, say okay, replace with the mean. Then you will replace for the whole data. Okay? That's why tomorrow I will show you. Because here is not existing in this computer. There is one function here. So now let's go to the second step, because we have, I think already we already now 12, I think, right? Yes. So we just start with missing data. So now find and report the outliers. So why we need to find and report the outliers? Because as I told you here, some maybe they key 7 instead of 4 or 5, right? So by mistake you key 7 or you key 6 or you key 8. So then how to find the outliers? We will show you here how to find it. So let me just close this out. Okay, here. See, now the outliers, just say analyze, you go for discrepity, you go for explore. This one, explore. So now in explore here you need to key all, you need just to key one variables. Let's say I do it for analyze, explore. You select here outlier. This one. Continue, then I key the variables. Then load. Let's make here histogram. Okay, so for this one, what you will do, analyze, discrepity, explore, you key the variables, all the items. Until here, you key them here. Then you go for plot, you click histogram, then continue, you go for statistics, you select outlier. Then continue, then okay. Just you go to the plot. This is the most important for you. You do directly one by one. You say here, the first, this is what the name of the variables, SUB1. Where is SUB? Here. SUB1, right? If you see here, where is the plot? Okay. The one who has see here. This is show the data normal distribution here. The outliers, the values is here. See here you have observation number 250 and 248, 247, 246. For these variables or for these items, for this item SUB2, we have 4 cases are represented as outliers. Okay, so then you have to record how many outliers for these items. Then I go to check also for the second item. These items I don't have any outliers. Then I check the third one. This one also no any outliers. This one, here we have many, the same also, 247, 218, 79, 225, 214, 235, I have first to record the outliers. You record the outliers. Then here you write, you arrange them. The number, then case number. Okay? So here 1, 2, 3, 4, 5, 6, 7. Then I go to the case number. When you come to arrange the case number, try to arrange them from the highest to the lowest. You know why? Because when you drop them, you start from the highest one. If you drop from the first one, the data will replace. The last will be the last will be the first. Then the number will change. Okay? So I will show you. For example, here, let's just say these variables. What's the name of the variables? SUB5. How many cases we have? 1, 2, 3, 4, 5, 6, 7. We have 7 cases. So here we start with the highest one. Which one? 2, 2, 5, right? No, 2, 3, 5. 2, 4, 1. 2, 4, 3. I just say here 2, 4, 3. Then 2, 4, 1. Then
247 first.
where is it? Oh, okay. 2, 4, 7. 2, 4, 3.
4, 3.
2, 4,
2,
1.
4, 1.
Then
2, 3, 5.
2, 3, 5. Then
2 to 5.
2, 2, 5.
5.
218.
218.
79.
And 9.
So you arrange like this. Now when I come to drop the data, because this outlier you have to delete it from your data. But you will not delete only for these variables. You need to drop the case itself, the survey itself. You need to drop it. So when you drop, see why we need to start from the last. Because see, for example here, if I drop number here, this is the case number, right? Let me arrange them here. This index, right?
Yeah.
Now from 1 to 250.
Yeah.
So if I drop, let's say this one, 241, or if let's say I drop this one first, 7, 9, right? Now when I drop 7, 9,
Yeah.
7, 9, right?
7, 9. This one.
This one. Now when I drop 7, 9, I delete it. Number 80 will be 7, 9.
7, 9.
So then the data, the rest will be wrong.
Yeah.
Then you have to start from the last one. Otherwise, you will the one you drop, the first one you will drop correctly, but the rest will be wrong because the data will go up. then they will replace the number. So then you have to start from the last. Okay? You have to start here. When I start from this one. Because when I drop the last one, this one will go up, but the previous one will keep constant. Then and then so on. Okay? When you come to drop, you drop the one with the lowest value. I mean with the highest value.
Yes.
Okay? So this is the way how to drop the missing data. Why the outliers? Why we need to drop the outliers? Because outliers will lead to a normal distribution of the data. See, for example, why we call them outliers? Let's say the data is here, the data of the salary of this company. We have this say 4 students, 4 staff. One received 100 ringgit. The second one is 200. The third one is 100. The last one is received 10,000. Okay? Now, if I want to get the average, if I ask you the average salary in your company, what you will do? You will do directly the average will be 10,000. 10,400, right? Divided 4. How much? It will be 2,600, right? 2,600. So now when I ask you how much the salary in your organization, the average salary, you will give me this figure, right? But this one represents the reality?
No.
All the people got only 100 ringgit, 200 ringgit. Only one person gets 10,000. So this one we consider it outlier because it will affect the reality. That's why we need to drop the outliers from our data. Because if the outliers still there, it gives a wrong estimation about the reality. Okay? So now the second one, describe your data.
So we just remove it like.
Yeah, we drop it from the data, or the outliers should be dropped. Otherwise, your data, the normal distribution, the data will not be normally distributed.
So delete one by one.
Yes, you drop, but you have to drop from the last,
From the
the highest case number. Drop the highest case number, then the second one. You arrange them from the highest to the lowest. Then you start drop from the highest one. Because I told you, when you drop, the data will go up. Okay, I give you one example. Okay, let's say here, I drop this one, I delete this one, the number 80 will be 79. So then, when I come to drop the second one, the number that I select, it will be wrong. It will not represent the outliers case. It will represent the second one. Okay? See, for example, now I delete this one. See, clear. Now the 80 become 79. So that's why we need to take care about this one issues. See here, this is what now. This is the ID, right? Let's say I drop the ID 80 here. Now see, this one it was 80 become in front of 79. It's go up. So that's why you need to start from the last one. Anyway, now let's go to the second step because no time. Descriptive statistics. When before you do the analysis, you have to describe your data. You have to describe the central tendency of your data. Then you describe also the deviation, the separation and also the distribution. Why we need to do these things? Because central tendency, you need to know the mean and the median and the mode of your data. For distribution, you need to know the standard deviation and the range, variance, minimum and maximum. Then for distribution, you need to measure the normality. So after you run, you delete all the outliers, you have to check also the normality. If the data is not normal, also you need again to check the outliers until the data become normal. Otherwise, you cannot use normal regression. You have to do logistic regression for your analysis. So for descriptive, just very simple. You just go here, analyze, descriptive. So now we go to the variables. But when we come to descriptive, we have to describe the variables, not the items. We have to make, we call it multivariate descriptive. So in multivariate descriptive, you need to create the variables first. You need to create the variables. How to create the variables? Like here we have supervision 1 until supervision 6. You need to sum, divide the numbers. You take the mean or the average. Then we create like new variables. Because see, here is what? This is the factors. And this is the items. I sum all the items, divided the number of items, the number of observation, then I will find the figure. This figure I will put it here. Because this one represents the mean. Okay? First what you will do, you need to find the mean. How to find the mean? I have done it for you here, actually, at the end of this one. See, here, this is the variables I already created. Supervision, job satisfaction, payment, justice, and promotion. But to do it, just I give you one example how to do it, then the others you just give it. This say here, supervisions, I delete it now. Clear it. Now I do it again. You go for transform, compute, then you write supervisions, the name of the variable there. So here there is two ways. Either to take the mean from here, you click on statistical, you select mean. Then in mean here, you click on this one, supervision. Then the last one, number 6. So that's mean the mean from 1 to 6. Then the system will calculate it. If you cannot do like this one, what you do? You just make like normal calculator. You use here equal. You open bracket. Then you say this one plus this one, second one, then the third, then then 5, 6. Then you close the bracket. Then you make divide. How many we have?
6.
6. Then you will get the mean. The same idea. Okay? It's like just no. This is like calculator. So then you just say okay. No need to make equal. Just without equal. Yes. If you check now your data here, you will find new variable already created. This one. See, and this is the values. It's only the mean. Okay. So now I go to descriptive based on. I describe the variables based on. I describe the variables, not the items. This is the variables. Like supervision, I just sum the items, divided the number of items, then I create new variables. Same I did with job satisfaction, payment, justice, and promotion. Okay. So now you have to learn how to describe. This one is just very simple, right? You can do it even manual. But just now learn how to describe, analyze, discriminate here. You don't need to key, you have to key only those variables here. The one we create. Okay? So you key this one here, then option. Then option, we said we have to describe three things. Central tendency of the data, dispersion, and distribution. In central tendency, we need to describe the mean and then the mode. We don't have mode here, right? In some software like in IIiBF, we have mode and median, but in SPSS only they have the mean. You just click on the mean. Okay? But if you use or SATA, there is a median mode. Okay? And you know the difference between mean and median and mode. Some of you doesn't know, right?
Yeah.
Okay, mean here. This is, for example, here. When I said mean is the average. Like now I sum them, divided 4, comes to 1,600. When I say the median, you have to arrange the data from the smallest to the highest. Let's say 100, 100, 200, then 10,000. So then the median of this data is, this is the median, the middle one. Here, because the median is 2 numbers, then you have to sum divided 2. It will be 300 divided 2, it will be 150. This is the median. The mode, the number that is more frequent, has more frequency in the data. We say here, which one has more frequency?
100.
100, it's repeat 2 times. So then the mode is 100. That is the how to describe the central tendency. Then we have to describe the dispersion, because when we come to the data distribution, we have to see, this is the mean, right?
Yeah.
When we come to the data distribution, the mean is 2,600. Then I have to draw all those values. Here 100, then 200, then we have, let's say here, 10,000. So now I want to see how much each value is far from the mean of the data. This one, the variance. The variance, how each value is far from the mean of the data. We call it the variance. The standard deviation is measuring the deviation between each variance of the data. Then we have range. When we talk about the range, this is the data is from here, right? You have to arrange the data from the smallest to the highest. So now the range is, when we calculate the range, it will be what? The highest value minus the smallest value. If you see the highest value, how much? 10. Sorry, 10,000. Minus the smallest, 100. Then it will be 10,900. This is the range. If I ask you about the minimum value, then the minimum here, 100. The maximum, 10,000. Okay? If I ask you about the standard deviation and variance, you have to use the formula. Standard for the variance, it will be x minus x bar divided n minus 1. Yes, no, yeah, n minus 1. Then you will find the variance. What is x bar? X bar is the mean. That's why we said how each value is far from the mean. Divided n minus 1, which is the number of observation. Then you will find the variance. If you are looking for the standard deviation only, it will be the root square of x minus x bar here, square, x minus x bar square divided n minus 1. So this is the standard deviation. Then we come to describe the normality. here the data. You want to describe whether the data is squared because the distribution should be like this. But according to these values, this means the data is squared to the right. It's here only. There is no data on the left side. So we call it squared to the right. So the normal data should be near from the mean. The square, the distribution should be from both sides equal, or should be, all of them should be near from the mean. If it is far from the mean, this means the data not normally distributed. Then the cortices also is give an indication for outliers. Usually in data we have here like this. This one is the cortices value should be 3. If the distribution of the cortices is more than the rule of thumb, then we consider there is outliers. Then we go back to the outlier test to eliminate the outliers data from your data. Okay, now we go to variance. Then range, I think you can click on range. Squareness, cortices. Then set continue. Then okay. So this is the descriptive statistics table, which include all the information. You see here, this is what here, the name of your variables. And this one is the range. Here number of observation. Range, minimum, maximum, mean, standard deviation, variance, squareness, and cortices is here. This is the cortices. Cortices is refer for squareness and cortices refer for the normality. If you see here, the rule of thumb for normality in social science, it should be this one. Squareness should be less than 3. For cortices should be less than 5. Okay?
See that all items?
Not items. This one we said the variables.
All variables?
Yes.
For example, for me, I have socioeconomic characteristics as a variable. Should I say that?
Yes, all the variables in your data you have to describe them. If any variables you find is not, for example, not normally distributed, then you have to check the outliers of that variable. Then you include it.
For example, for me, I have socioeconomic characteristics. I have income. So the income, I cannot check the outliers for income because it is limited. So when I perform the normality, I don't.
It's not normal.
Yeah. So
It's not normal. No, you have to make you have to transfer. Your data is secondary data. It's not primary data. Secondary data, primary data. Your data, you're talking about income, right?
income.
So income is secondary data. In secondary data, this one is time series data. It's not cross-sectional data. You have to transform your data using the logarithm. You have to use the phase difference or logarithm in order to eliminate the effect of outliers. Yes. Because here, this one is this one from survey, Likert scale from 1 to 5. But in your data, you cannot even use SPSS for your data. Because unless if you have only for 1 year. But with the income for how many years?
Also, the income of the participants, of the respondents.
Oh, in the demographic variable?
Yeah.
No, you don't need to describe the demographic. Because demographic is not considered as a variable.
But in my study, it's considered as a variable.
Then you don't need to describe here in the model because the demographic is not here in this formula. Demographic can work as a mediating, as a moderating. That's one we will come in, inshallah, afternoon. We will discuss that one. Okay, now after we make the descriptive statistics, we go to the second.
The rule of thumb of the
squares and the
For squareness, we said should be less than 3.
less than 3.
If the statistical value is less than 3, we accept the variable as normal distributed. This one with just only survey data. But when it comes to the economic data, the squareness should be less than 1. For cortices should be less than 3. But for survey data, according to the HER 2010, they say the squareness, if it is less than 3, then we consider the variable is normally distributed. For cortices, if it is less than 5, we consider it is normally distributed.
Which one of this?
HER 2010. Yes. You can check the reference in the HER 2010.
Sir,
Can you spell the hair, please?
HER 2010.
What was the spelling? Ish?
HAIR.
Okay, that's
Bukan dalam statement.
HER 2010.
nice.
Prof. If my skewness is under than 3, but my kurtosis result is more than 5.
Then you have to check the outliers because that means there is a problem.
There is a problem in the
Yes.
outliers.
So now, okay, this is how to describe your variable. Then now we go to the second step. After we describe the data, we go for statistical assumptions. What we done before is only data screening. Data screening and also to describe the behavior of our variables. Now we have to come to fulfill the assumption of statistical assumption. If those statistical assumptions not achieved, you cannot run the regression because your result estimation will be wrong. All those assumptions should be achieved. The first one is the normality. And you know how to test the normality. We use squareness and cortices, that's all. Right? We use squareness and cortices, the one we have here. And this is the rule of thumb, see? Should be between -1 and +1. This one with what? With the secondary data, like economic data, the one you are using. But this one with survey data should be less than 3. For cortices, this one this slide I did it actually last time for okay, you can just change it here. You can make here -3, 3. Here make 5. Okay. This one only for survey data, but for econometrics data, -1, +1, here 3.
So 3, 3 for which data?
For survey, the one we are using for the questionnaire. For questionnaire, we use this rule of thumb. But for secondary data, like for example stock market price, these things, the normality should be -1, +1. Because some of you use secondary data, right? Yes. Some of you, they are using secondary data for their thesis or for their research. But some of you, just they need to do questionnaire, right? For questionnaire, this is the rule of thumb. For secondary data, just change this one, -1, +1, here make it make it 3 instead of 5. And in some study also, they said this one can be 10.
Sir,
Yeah.
if we calculate the variable, let's say the variable, the curtosis is greater than 5, is it we need to drop out the variable from our activities?
The outliers. Yes, you need to drop it because otherwise it will lead to bias distribution, bias estimation. Because outliers you cannot accept it in your data. If you keep it in your data, your estimation, whatever the result you find here is not represent the reality. Okay. But for secondary data, there is many ways to eliminate the normality. You can use logarithm, or you use the phase difference, or you use the growth rate instead to use the value of the value itself. Let's say, for example, in GDP. GDP is in million, right? Or in billion. 10 billion. So I cannot use, I use these figures. Sometimes it gets, the distribution becomes not normal. Then what I do, I take the logarithm. Then it gives me like only maybe 10.
So these will be done by the eView scale software, not SPSS, right?
Yeah, you can do it in Excel, the logarithm. This one is just very simple. You go to the Excel, for example here, this one, let's say here 10,000. Here. Then if I want to do logarithm, just say equal, then make L or G. Then open the bracket, put this figure here. Now it's become only 5. This is the values. Instead of to use those values, I just use this one. Then when I come to run the normality, it becomes normal distribution. Because the variance is become very high when it is in billion. Because sometimes in the model, in your model, for example, what you have in your model, let's say you have interest rate. You have interest rate. Then you have money supply. Then you have GDP. Let's say money supply is percentage, right? Sorry, percentage. The interest rate is percentage, right? Let's say 10% or 30%. But money supply is 100 billion, right? So then, how to run? There is different level of variance. If you use just the data directly like this, it will not be correct. I mean, you will find those variables are not normally distributed. Then first you need to load the data. This one is secondary data. Inshallah, when we do one workshop in econometrics, then we can handle all these issues. But just now, just focus on your survey data. Because I'm sure those who use, because SPSS is not suitable with any type of data, only with cross-sectional data. Because we have 4 types of data. We have time series data, we have penal data, we have cross-sectional, we have survey. Survey also is not applicable with SPSS. Okay? You have to use AMOS. Because the error term here in the model, here, when we have the error term, each variable has different level of error term. You cannot assume all the variables has the same error term. So then you cannot use SPSS. You have to use AMOS. But just now you have to learn it. You learn how to run SPSS. But then when you come to your thesis, you have to see which type of data you are using, and then which model is related to your data and which software. Okay? Just now we learn how to run SPSS. This is the idea. But when you come to do your real analysis, you have to check which type of data you have. You have questionnaire, then you have to use AMOS. If you have cross-sectional data, SPSS is the best model to use.
But before running AMOS, we have to pass by some steps.
Yeah, the assumption you can use it because AMOS is run based on SPSS. SPSS is the software. You know, you have to distinguish also between software and model. When we say OLS, that means we use cross-sectional data with OLS. That's we are using it in SPSS. But when we come to AMOS, we use different model. We call it structural equation model. When we use econometrics, we have different model. We have VAR, VSEM, we have art and cash, we have RDL model, and so on. So it's based on the data and based on the model. This AMOS, SPSS, the others is only software. Okay, you have to distinguish between software and the model. Yes, bro.
Yes. Data were collected for a particular survey.
Yes.
Regarding transportation and emissions. It's another research.
Yes.
Questionnaires were not used. So what we did was to calibrate the timing for each of the buses when they arrive at a particular bus station and the time they leave the bus station, like the wait time. Would you recommend SPSS for such a research?
For the data?
Yeah.
No, this data is questionnaire or what?
It's not questionnaire, it's survey, observation.
Observation,
We
okay.
only noted what time did the buses arrive.
Yeah, this one you can use SPSS because it's not time series data. This one is just only like you have one observation for each case. But if you have like 3 observations for one case, so that means there is a time. Like you observe this case today, then tomorrow and after tomorrow. Then you want to see the difference. Here you have to use econometrics model.
Exactly. I think it's almost similar to what you just described. Because, okay, in the real sense, let's say the campus shuttle, they have different buses that go to campus and the town, but they operate at different times. The same bus, or different buses, but we tag it as just one bus to avoid confusion. So, but this bus comes maybe every 30 minutes.
This one, yeah, I agree with you. But this one, what you are looking for? You are looking for cause and effect or compare. I'm sure you are looking for compare mean.
Okay, both actually. We're looking for, because this bus is not the only bus we examine other buses using the same facility. So
Yeah,
that is compare.
Compare, yeah, that's when you have to use, that's why at the beginning I said you have to determine between cause and effect relationship and the mean, the compare mean. When we use compare mean, we have to use the 3, one symbol or 2 symbol or multi. When it is multi, like you have 3 or 4 bus, and you want to see which one is whether there is a difference in terms of reaching to the bus station at the same time, or I mean you have to measure these things. Then you have to use ANOVA because you are comparing 3 level or 4 level of different bus, and in terms of the time or in terms of anything. But this one not cause and effect relationship. This one is comparing with. Yes. That's one you can use ANOVA if they are more than 2 bus. If it is 3 or 4, then you use ANOVA. If this, you can use the t-test. Because t-symbol test or 2 independent or based on the type of data you have.
Sir, yeah, sorry again. Actually, we were using the ANOVA is the plan, but again with this explanation, I'm like, each entry, each bus has about 15 entries. Because throughout the day, they came, leave, go. So what we did was to look at the difference between the arrival and the departure. We gave them the timing.
Yeah.
And that timing is used for the analysis. So we have 5 buses or about 6 buses. All along.
Yeah, that's one is you need to compare these. There is no any cost on this. Because you are not looking at the cost of delay, or you are looking which one is reached early and is your objective. So, okay, now we said if there is a problem with normality, you have to log the data. This one is the secondary data, and maybe inshallah in the next workshop we will do it. So for survey, there is no, you cannot make log from 1 to 5. You cannot log the data. Just you have to check the normality, use outliers, then you drop the case directly. Then the variables will be normally distributed. So now let's go to the second step. We said normality, we know how to test the normality, right? We use skewness cortices. If you want to learn it, just do like this. Analyze, descriptive, here, descriptive, then I go to the option, I just no need all these things. What I need, only normality. How to measure the normality? I use skewness and cortices. Skewness to check whether the data is distributed to the right side or to the left side. Cortices, you see the whether the data is out of the what they call it, the normality. If it is more than 3, then you can consider it as not normal, then you go to check the outlier. So this is the result, then you will find that this is the result. This is the cortices, this is the scoliosis. And according to the rule of thumb here we said 3, negative 3, positive 3 for squareness. Here 5, you check here. Where is it? Here. All of them less. This one less than 3, less than 5. This one less than 3. So then we consider all the variables are normally distributed. Okay? Let's go now to the second step. Multicollinearity. You have to check also the multicollinearity between the dependent and between the independent variables. Why we need to check the multicollinearity? So what is multicollinearity means? Multicollinearity means there is a high correlation between two independent variables. Not dependent and independent, between two independent variables. So if there is a high correlation between two independent variables, you need to drop one of those variables. Otherwise, the data will consider as what they call it, redundant information. You know what means redundant information? Like for example, I send 2 students to represent IIiBF. So both of them is represent the same institute. Then we don't need to send both. We need only to send one. If we send both, then it may cause such problem. Then you have to only send. You have only to keep one, and the another one you have to drop it from your analysis. Because usually multicollinearity, it will cause spurious regression. Will lead to the R square. The goodness fit of this model will be very high. Sometimes you find 99% or maybe 100%, and that's 100% wrong. And why this? There is a high R square because of such multicollinearity. So what you will do to test the multicollinearity? You just go to here. Analyze. Then you go for regression. Okay, analyze, regression, linear. So now in our model is what we say here. Our dependent variable is job satisfaction, right? Our independent supervisions, then payment, job stress, and also promotion. ERM, then so then you go to the dependent variable, job satisfaction, the others variables. Here you just see what is this dependent variables, which means this part of the formula. Part. Independent variables, which means those the others, right? I just put here dependent. Here we have independent. Independent usually can be many, right? Because we call it multiple regression. This one only one. So then here you select entire, because there is many methods that you select entire. Then from statistics you need to select R square. We need to select here because we need to test only collinearity, right? You select this one, collinearity. Select this one, the collinearity. Then we say OK. Then make OK. See, the result is here. This one, coefficient. You select, you go to this table. Here at the end of the table we have 2 tests. One we call it tolerance. The second one is variance inflation factors. This test, it shows whether there is a multicollinearity between the independent variables or not. How much the rule of thumb for variance inflation factor, they said should be less than 5. Okay, it should be less than 5. If you see here in your data, all of them less than 5. And I wrote to you here the rule of thumb. Less than 5. Okay? So now we confirm there is no multicollinearity in our model. So then the second assumption is achieved because we have normality, multicollinearity, correlation, then linearity and homophylicity. Those should achieve, right? Now two already done. Now we go to the third one, correlation between the IBs. Why we need to find the correlation? Because if those variables, there is no correlation between them, that means they are not represent one community. When you select the population or you select the symbol of your study, show those people represent one community of your study. If one is out of the community, then we cannot consider it as, we cannot use it for estimate our relationship, right? You have to select the variables, the one has a correlation but not high correlation. If they have high correlation, it will cause to multicollinearity. They're supposed to be, the correlation should be less than 90%. If it is more than 90, that means it should be more than 0 and less than 90. If it is 0, that means that variable is not related to this group. We have to drop it. If it is more than 90, also there is another issue. Because if two students, they have high relationship. So this means they are represent each other. Then you need to only keep one. You don't need to keep both in the model. So now to run the correlation, just you do here. You just follow me, then analyze. Then you go for correlate. Okay, analyze, correlate. Then bifurcate. So now I select. But see here, you have to select only the dependent, the independent variables. Correlation only between the independent, not between the dependent and independent. You shouldn't include this variable. Only include the independent variables. Okay? Because this is the idea. So here, job satisfaction, we said represent the dependent. We shouldn't include, right? Then we just choose from here. This is here option. You don't need to change anything. Just here you select person. We select person, and this one we use them when our dependent variables are categorical or nominal. We can select the Kendall and Superman. But for this data, because it is Likert scale, just use person.
So when data is nominal, then we select this.
You can select either this one or this
And
one.
ordinal? Ordinal?
Same also.
Only numerical we should select Pearson.
Yes, yes. Then you make okay. See, now this is the correlation. Here you can ignore this one because what you have here is already, this is the diagonal, should be 100%. The data is out of the diagonal is the same data of the one is under the diagonal, like this one, like BB, bay with bay, like the variables relationship to itself is 100%, right?
Yes.
But Josh test with bay is 56%. Then promotion with bay is 60. And if you check all of them here, all of them are less than 90. And all of them more than 0. So then the correlation, according to the result of the correlation matrix here, we establish the satisfactory degree of relationship between the independent variables, as well as there is no multicollinearity because all of them less than 90. constant, there is no multicollinearity because correlation matrix it has two functions. First, to establish the degree of relationship between the independent variables. The second function is to find the multicollinearity. Where we can say there is a multicollinearity if the correlation is more than 90. But here, according to this result, all of them is than 90 and all of them more than 0. So that means we establish satisfactory degree of relationship between the independent variables. So now the third assumption is achieved, right? Now we go to the linearity assumption. Linearity means what? The data, the relationship between dependent and independent variables should be linear. Remember when we draw here morning, when we draw this one, we say here is the constant, right? Or we call it T0. This one is the Bi, or we call it the slope. Okay? And this one is X, this one is Y. So the data here, this one is what? Linear. Linear, right? Linear relationship. When this linearity should be, this assumption should be achieved in your model. If there is no linear relationship, so this means that the independent variables will not predict the behavior of dependent variables. The X will not be able to predict the behavior of Y. Okay? Because see, when X increase, Y will increase, right? If this not existing, this relationship, then so that means there is no linearity between the variables. Now we go to check the linearity. Let's see, analyze, then regression, then linear. Just you can record those steps. Analyze, regression, linear. So you put here the dependent variables and the independent here. Then you go to plot. In plot here you have Z predicted and you have Z residual. You make Z predicted for X. Like the X predict Y is the idea. And here the residual in Y, because the residual of the Y, which means this one, the error tail, which is the difference between the Y and Y bar. Okay? Or we call it between the Y and the estimated Y. So now you just do here. Z predicted, we put it here, and Z residual, we put it in Y. Then we click here, histogram, normality, this one. Then okay, then okay. This is the linearity, see? This is the data. Data should be linear. You see the data is, here it's not 100% linear, but quite good. The assumption is there. Achieved. When it is not linear, you will find this case, here the case, you will find some value here, some value here, some value here. I mean it is not,
Yeah, S here.
Yes. Here is linear. That means there is a relationship between the dependent and independent variable. Okay, see here, this is the dependent and this one is the independent. Okay? Now it's clear? So then the fourth assumption is achieved. And also in terms of homopedisticity. See, this one also represents the homopedisticity. Like each variable, the variance for each variable, they are constant. When we say homopedisticity and heteropedisticity, homopedisticity means the variance, this is the variable's behavior, and this is the mean. So then the data is keep variance like this. So if you see here, this is constant variance, and this is the mean. The data keep vary around their mean, but with the same level of variance. That means they have constant variance. We call it homocodicity. When there is heterocodicity, that means the variance will be like this. Then we will see the mean here, and different mean, and different variance. So we call it heterocodicity. Then we cannot use this model with this type of data. But if you see here, how many variables we have? We have 5, right? 1, 2, 3, 4, 5, and all of them they are their variance in the same level. Okay, that means the homocodicity assumption also is achieved.
Prof.
Yes.
Can you explain again that correlation point? Is it fulfilled or not? The correlation.
Which one?
Correlation. Correlation.
Linearity, you mean?
No. Correlation. Previous one. C.
Correlation.
Yeah.
This one we already done it here. Where is the root now? Here.
Yeah.
Because we say
Is it accepted or rejected?
here accepted, because the rule of thumb we said should be more than 0 and less than 90. And if you see here, all the value, this one they don't care about this one and this one. Just see here.
Okay.
This is the
Only
correlation.
Pearson correlation.
Yes. If you see here, all of them is significant with 2 stars. All of them significant.
Should be more than 0, less than 90.
90.
And it will reflect on correlation and multicollinearity both.
If it is more than 90, it
Then
will
it,
reflect there is a multicollinearity.
multicollinearity.
But if it is less, it's refer there is no multicollinearity.
Okay.
Yes. Okay, now, see here now, the third assumption is, the last assumption is achieved. We said linearity and homocodicity. Now we go for, now after we all the assumption achieved, now we can run our model. We can run our model, then the estimation will be correct. But before, if any assumption not achieved there, then the estimation, the coefficient, because what we are looking for this slope actually. This is the value we are looking for from our analysis. What is this value? This one is represent how much X can explain the behavior of Y, can contribute to predict the behavior of Y. This is the idea. So that's what we are looking for. This one is represent the beta. This one, like 1% increase in Y in X will lead to decrease or increase in Y. This is the main idea. But to find this one, you have to go through all the process. Okay? So now we said we have 2 types of tests. We have simple test and we have multiple multiplication. For this model, consider as multiple. Why? Because we have more than
one variable.
More than independent variables.
More than one.
This one independent, that's one dependent. So when we have more than one, we call it multiple. So now just we run it, we see the result. We go to analyze, regression, okay, then linear. Then you have here, you keep here the dependent variables, then the independent. You keep here the dependent variables and independent here. Then you select entire. Okay? Then you go to statistics. Now we need to select the R square. Then multicollinearity we don't need because we already mentioned that. Just you need to select here R square. You select R square. This one also Dorban Weston. Continue. Then you select plot. This one already done it to check the linearity. You don't need it anymore. Then you just say okay. Now this is the result of our model. of this model. This is the result. What you will find here, this is R, this is the R square. What is R square? This one we call it the goodness fit of the model. Like, now we have how many variables in our model? How many variables we have? 1, 2, 3, 4. Yes.
Independent variables.
Yes. The overall, how I ask you how much those variables contribute to explain the behavior of Y. This is you can answer by the R square, like 56%. You can say the job satisfaction is determined by supervision, payment, justice, and promotion by 56%. So that means there is another variable is not there, right?
Yeah.
That's why we represent the error term. Is the difference between the Y and the estimated. Okay? But what we those variable only the one include only explain 45 or 56%. So that means the variables we include in our model has the ability to explain the job satisfaction by 56%. Maybe there is such variable is not in our model. So this the difference between Y and the estimated Y. The difference is represent the error term. That means there is such variable we didn't consider in our study. Maybe the other researcher will come and explore it in the future, right? This is the idea. So now it's okay. This one is clear.
Yeah.
So this one we call it. We use R square, and then we can use adjust R square. So now also here another indicators to see whether the variables that we select is appropriate or not, or they are related or not. We have to check with global F test. Global F test here, if it is significant, that means the variables that we select are related to the job satisfaction. If this one not significant, so that means the variables we select is wrong, then we have to go back to the theory. Because you cannot, because when in statistics you can select anything, then the software will give you result, right? But if this one not significant, that means the variable you select is not related. The variable you select, they are not related to explain the behavior of your dependent variables. You have to look, to go back to the theory and the literature, then find the variable. This is the idea. Okay? So now you go to, yes.
But what the function of adjusted R square?
Adjusted R square, actually, you know, sometimes there is this one, the adjusted R square, usually we use the adjusted one.
Adjusted.
Because some, there is some issue in the model for the estimation. Then when you use the adjust, it will give you the accurate one. Yeah, but I will check for this one. I'm not sure exactly what, but usually we use adjusted R
Because
square.
we use it in our kulliyah. We use R square and adjusted R square in
But
design of
we rely on
experiment.
adjust.
Yeah, but
Usually
it's not clear
adjust,
for me.
adjust R square is less than the R square. Because this one gives you the accurate, or maybe this one is based on they calculate based on the standard error.
Standard.
Because we have like unstandardized and standardized.
Yeah, it's
Then this one gives you with the standardized. Like for example, when you use log natural data and use logarithm data, the value is become more accurate because the data is like include such issues. Then when you make the standardized, it become more accurate and more robust. Okay? Like for I will show you here. See here. This is the beta. You have here. What is it? You have here beta and you have beta here. Two beta. This one normal beta and this one with the standardized. So that's one also the same. When we make R square and adjust is based on the standardized values, which is more accurate. If you see here, sometimes you will find this figure is different than this figure, which means this one is the more accurate one. Okay? Okay, now after we run this one, we find first how much the overall explain the behavior of Y. Then we find 56.4%. Now we want to learn how much each one explain the behavior of Y. This one R square is give you the overall model. To find for each one, you have to go for beta here. This one the beta. Remember here, this is the coefficient, which is this one. But here for each x, but here you have many x, right? You have 4, right? 1, 2, 3, 4. So for overall, the beta is, or the correlation is this one. But now for each individual one, we have to find from this table. This is now 24%. So now what we can say? We can say the supervision's level, if the supervision increased by 1%, will lead to increase the degree of satisfaction by 42%. The same also here for, this one for payment, sorry. If we say you increase the salary by, let's say 100 ringgit, that will lead to increase the satisfaction for the employees by 42%. You see here, the highest one is the payment, the salary. That means people they feel more satisfied with money. Give them money, they will satisfy in their job. They don't care about the other things. But see here also the significant level you have to check here. Now we come back again to the t-test. You remember?
Yeah.
Yes, sir.
The same also here. The t-test you have to see this is the value and this is the significant level. Just compare here. Because your hypothesis now based on each individual variables. Yeah. This one is analysis. What will here. Yeah, this one is just the steps. Like for example, you run your regression, then what you run the remaining case. Oh yeah, we will go to play. We will go to play. We'll come back. Yeah, sure. Okay, for now we just stop until here. We go to break because the workshop until 5, right?
Yes, sir.
So we go, we break, then we come, we continue with regression. After regression, we go with mediating and moderating using SPSS. Okay, then the workshop will finish, but it will be that one until 5. Yes. Then tomorrow, inshallah, we will continue to do this.
Jazakallah. Thank you very much. Yes. Assalamu alaikum wa barakatuh. We have 1 hour. We're resuming at 2 for the other part of the lecture. 2 things. The lunch is ready and it's there. If you have not registered, please meet my colleague out there. We'll be willing to register you. Assalamu alaikum.
Students, inshallah, see you after noon, at 2. For the steps for the regression is already there in the yeah. I have done it. Based on our square is not important. Individual variable, how much? Because your hypothesis is based on individual variables. Yeah. Do you have any question? Of course, no, right? Keep the dependent variable here, then the independent variable here. Then you can select here the entire. Okay. So for statistics, here you can select the model field, which includes R squared, and you can also select the collinearity, the Dorban Wilson test. Then we go for float. We said for float we select here R for X, R predicted for X, and Z residual for Y. Then we make continue. Here you can select also for histogram. This one is short. We draw the normality distribution by histogram. Then normality probability flow. Then continue. Then here option. This one if you want to change the level of significance. Then let's make okay. So now this is the summary of the model. This is the summary of the model which show the goodness fit of the model, which is R squared, or we say that just R squared. Okay, and also here the ANOVA, which indicate whether the variables that we use as independent variables has enough ability to explain the behavior of the dependent variables. Okay? If this one significant, then we compare the variable we select is appropriate to explain the behavior of the dependent variables. But you need to get also theoretical justification. You cannot choose the variables by yourself, right? Should be there is a logical relationship and also theoretical relationship. Then the estimation coefficient. This is what you are looking for. This is your hypothesis. When you write your research question and research objective, for example, in this model we have 4 objectives, right? The first objective is to examine the effect of payment on job satisfaction. The second objective to measure the effect of justice on the job satisfaction. Then to measure the effect of the promotion on the job satisfaction and the supervision on the job satisfaction. So that means we have 4 objectives, 4 research questions, and then 4 hypotheses. Because the hypothesis for this one was payment have significant effect or influence on the dependent variable. Then same also, justice has a significant impact. This one, when we say the hypothesis here, we say directly the alternative, not the null, right? Because we say at the beginning, today morning, we say for null, this one is the default one. For HA or the alternative, which is the researcher hypothesis. That's what we are looking for, right? We reject this one. When we reject this one, we accept the alternative. This is our target. Okay. So then, this is our hypothesis, what we test, and now we want to check whether these variables are significant or not significant. Right? For example, here, our null hypothesis what? We said, for example, the first one is what? The payment. You can say the salary or high salary, for example, high salary has significant influence on the job satisfaction. Okay. This is our hypothesis. And the null alternative, high salary has no significant influence on the job satisfaction. This is the idea. So if let's say here we say high salary, the same it will be high salary has not, here we just write not significant influence on the job satisfaction. So now based on this result, this is the t-test, right? So now we said we reject the t-test, we reject the null hypothesis if this one is less than 0.05. Now see, this one is 0.03, which is less than 0.05. So now what we will do, we reject the null hypothesis, which means we reject null, we accept the alternative. Mean high by men or high salary give significant influence on or significant impact on the job satisfaction. Okay? This is the idea how to interpret your result. Here also just test, we see the t-test and the significant label. Here significant label is less or more than 0.05.
Yes.
It's less, right? Yes. Yeah, then what we have to do with the null hypothesis? We have to reject, right? And accept the alternative, which means the job test has a significant influence on job satisfaction. Same also with promotion. But you check here, this one is more than 0.05. So then what we will do, we reject the null or we accept?
No, we accept the null.
We accept the null. Because we cannot reject here, right? We said we reject null if this one is less than 5. But this one is more. So then we accept the null and we reject the alternative. So this means the promotion doesn't have any significant influence on job satisfaction. Same with supervision. Also we check the significant label here. The clock is significant, right? So then we reject null. We accept alternative, which means the supervision has a significant influence on job satisfaction. Okay, it's clear? Okay. So this is the final decision you will reach to, because what you are when you did your research, you did it because you want to examine this to reach to this objective, or you examine your claim that those variables have a significant influence. So you already now prove that those variables significantly influence the job satisfaction. So now based on those variables, you can predict how to make your employee are satisfied in your company, right? Either to give them salary or to change the supervisor. You have to bring the one who can supervise them in a good way, or you have to be also provide the fair system or justice system.
JUS, that means justification.
This one? Justice.
Yeah.
This one is supervision. This one payment or salary. So if you see here, which one is the highest one? This one almost 100% sure that the salary is the most important point to make your employee satisfied. Then maybe the second one is the supervision, then the third one will be, and then you can check here from the coefficient. This one 43%, sorry here 42%. So this means increase the salary by 1% or by maybe let's say the salary usually is 1,000. If you increase the salary by 100 ringgit, will lead to increase the satisfaction among the employees by 42%. But if you give them a good supervisor, they may be satisfied by 19%. Okay? This is the idea how to interpret your result. So now we go for this one. We already explained, right? The linearity and those assumptions. See here, we have, this is the Godwin's fit of the model. we use R square or model significant F test and the parameter significant T test. You remember here, for model, the overall we use R square. The summary here. We use R square. If the R square is high, so that means the variable we select, they have a high ability to display the behavior or to predict the behavior of Y. The second one is we use F test to guide us or to indicate whether the variable we select is relevant or not relevant to the model. If you see here, F for the F test, if this one is significant, so that means the variable we select in the model are relevant to predict the behavior of Y. Then the third one, we use T test to check for each individual variable, right? The significance of each individual independent variable. Then here, strength of effect, beta coefficient here. This is the coefficient to determine the level of effect or impact. If this one high, that means that variable is significant, as well as you have to determine how much the percentage of each independent variable can contribute to predict the behavior of Y. Clear?
Yeah.
This one is clear? So then the last one is discussion on multipolarity, correlation matrix, and this one already we covered it early, right? Because if you see here, this one for multipolarity, this one. Variance inflation factors. We said we use variance inflation factors or tolerance. If the tolerance less than 1, there is no multipolarity. If the variance inflation factors less than 5, there is no multipolarity. And based on this result, there is no multipolarity, right, between independent variables. So then, I think that's all. This one just explains what we have. What is R square, what is the others, and the hypothesis for each parameter. So this one is when we have only, this one we call it simple regression, right? When we have one dependent, one independent, we call it simple. But when we have more than one, like 2 and more, we call it multiple regression. Like this one. Here we have 2, but in our model we have 4. Then we call it multiple regression. So now we go to test the effect of moderating and mediating. And this is the most important for you, because the previous one is just simple regression. I mean, it's easy to run it. So you need to learn how to test the mediating and moderating. And you need to understand also the concept of moderator and mediator. So based on our model, for example, we test first the moderator, right? The moderator. This we assume now. We assume this is the dependent variables, okay? Which is job satisfaction, right? Our independent variable is what? We have 4, right? We have stay, then we have justice, right? Yes, supervisions, and then promotion. This is our dependent variables. This is the framework of your model, right? And all those, this one we can say, let's say H0, H1, H2, 3, then H4, right? That's our hypothesis. So now, let's assume what? We have one variable work as a moderator. Like, for example, if we select here, usually moderator is, what they call it, demographic variables. We say, or we call it nominal. Let's assume here we have gender as a moderator, okay? This one moderator variable. So now you want to test whether the gender is moderate the relationship between payment and job satisfaction, because you want to see whether which one is they are more interesting for salary, whether male or female. Okay. So the objective of moderating is actually is what? To activate the relationship. The relationship should be existing. So that means if this moderator not here, there is a relationship between payment and job satisfaction, right? But now if I include the gender as moderator, then I want to see whether the relationship it will be more activated or not. It can be positive, it can be negative, right? But this one is not mediator. The mediator variable should be like this, the relationship, because the relationship between A and B cannot be occur unless there is a moderator. But here, unless there is a mediator. But moderator, there is a relationship, but this one increase the relationship or decrease. It motivates the relationship. Okay? So now we want to test the moderator variable, which is the gender. So how to test it? See here, you will have three types of variables. We have dependent.
Oh, sorry, sir. It will affect these two variables or all of them? Gender.
Now here you want to find the interaction, whether this one is affect the job satisfaction or here. The relationship.
These two.
Now we have this on this. This is C. This one we call DV. Sorry, IB. IB. This one is DV. This one is moderator variables. We have three categories of variables here. Before we have only two types of categories. We have dependent and independent, right? Now we have one more, moderator. So now we want to examine whether this variable is motivate the relationship between payment and job satisfaction or not. Okay? So here we include the gender as a moderator. So to test the moderator here, first you need to download this. Here there is one. Okay, this one. You can just copy this one. You go through the internet. Access is there. We need to download the process macro for SPSS. So here, download process B313. Then you need to save it. We save it here in document. Here, document, okay? Then save. Now you go to SPSS. You click on utilize. Then you select here okay, here you go to extension, you have custom dialog, continue, don't have usually from here. Often.
What it is.
Huh? Can you put your fingers here? This one, you know, usually we download it, then we go to SPSS, like here, we go to utilize, then here, they look custom, but it's not here. In your SPSS, do you have this one? Here, analyze. So this one. You have here custom dialog.
Which one, sir? Custom dialog. Custom dialog. Dialog ada itu bisa? Ada itu bisa?
Yes.
No, sir.
There is a video about this one. Okay, let me just see this video. They have the steps. So this see, this is the steps. So we go to our file here. Then we go for this one. Then we select this one. But this one is not
also.
The second one, sir.
Second one.
this one.
No, sir.
Not
Just exit the folder, sir. Yeah, this one, right?
Oh, here.
Yeah.
This one. What? Here, analyze. You go utilize. Dialog. Here, not dialog. It's not a mistake here. Here, extension.
There.
Here. Install custom dialog. This one. Okay, now we just choose it from. Okay, just now. Okay, here. We go to this one. Extension. Then we go to utilize. Then install custom dialog. So from here we select the file. It was in document, right? Document. Where is document here? I think I bought it there in my bin drive, right? In your file, right?
Yeah.
Okay, then I just copy it from here. IIiBF SPSS workshop, right?
Not ABF workshop.
IIiBF workshop. Okay, this one.
This one.
But it's not here.
You must extract them maybe.
Okay, again we do utilize. Sorry, extension. Utilize. Install custom dialog. So now we save it where? Document. This one document, right? So, but it's not there.
There. The extract file.
Huh? It's working from there, from the computer. But this one is not supposed to be. Yeah, like this. Download.
Remote. I think the remote expand the
Okay, if we download it again, download it again here. This one, right? Here. So then we make save, right? We make save. So we save it where now? Dialog. This one document. Let me save it in download, right? Here. Now it should be there, right? Now we go to
we must extract them.
okay, then come again.
Extract them.
Extract or extract?
Extract.
Where is the for the extraction?
Extract file.
Extract file with right click. It's not in the
file.
right click. Extract file.
This one.
This one.
Oh, okay. Then
Okay.
oh, okay. Now it will work.
And document.
Visualize. It will work now.
Process 33.
This one. So then. Now it's clear. Yes. You know why we download this one? Because before, if we run analyze here, regression, you will not find this one, process. So So we add it because if this one not existing, you have to do it manual, and there is a lot of progress. But this software is directly, they already done all the progress of all type of model. Okay, you just download this one in your computer. Download it in your computer. Now we try to just click on this one. See, this is what we have. Here we have the dependent variables. We have independent. We have the mediator. We have also here moderator. But when you come to select here mediator and moderator, you have to choose here because you have around 73 model, or no, we have 92 models. You have to select the appropriate model. For mediating, we select 4. For moderating, you select 1. Okay? Now we are going to test the moderator, right? This one, the moderator effect. So then you select 1 from here. This is, you select number 1. Number 1 refer to the moderator. Here, independent variables. Here, actually, what we are going to test, the effect of payment on job satisfaction through the using the we want to test actually whether the gender moderate the relationship between payment and job satisfaction. This is the idea. So you go to here. Our dependent variables is job satisfaction. Then our independent is the payment, right? So then our model is moderator, gender, right? This one. Then you put it here. So from here, from option, you go and select. See, those are related to the moderator. Just only here. Generate code for visually intermediation. You click on this one and this one. Because see, this one is mediation, indirect effect also for mediation. This one only for the model number 4, 6, 8, 81 because we have 92 model. So our model is number 1. Then we don't need to select this one. Here, create model for visualizing intermediation. This one. Just click here and this one, the last one. Okay, then the others don't select. You select this one and this one. Then you make continue. Also here you have to change. No, this is not going. You continue. Then you make okay. Here. This is the result now. This is job satisfaction. The dependent, independent, then the gender as a moderator. Now we go to check the result. The result is here. This is the effect of payment on dependent variables, which is significant, right? According to the probability here, the p-value is significant. Then the second one, gender on the on the dependent variables. Now, like this one, which is like this actually. First, you measure this one on the job satisfaction. Second one, gender with the job satisfaction. The third one, the interaction. This one times this one. The interaction, then the effect of on job satisfaction. This one will determine whether the gender is moderator or not. Yes. The interaction. If it is significant, then we can conclude that the gender is play as a moderator variables or moderate the relationship between payment and job satisfaction. So now see here. The direct one is significant. Gender doesn't have significant influence because the p-value is more than 50%. So the gender doesn't have direct because it's not significant, right? Yes. Now, if you see the interaction, this one, interaction is significant because it is less than 0.05. So now we can conclude that the gender play as, or the gender moderate the relationship between payment and job satisfaction. But now, which one is more influence the relationship, whether male or female? So then you have to check based on the level of the variables here. Now we have two coefficients. This one, the overall interaction. Now you have to check. You see here, this is the gender, right? And this one is represent for the previous one for male, the second one is for female. This is the coefficient for male, this one the coefficient of female. This one is the significant level. Both of them, they are significant, male and female. Okay? So this is the idea how to interpret your result. Because sometimes you will find only one part is significant, but the other one is not significant. But in this case, both male and female are significant. You can even draw this matrix. I can show you how to draw it. You can use this information to draw the matrix to see how the interaction between male and female regarding to to motivate the relationship between payment and job satisfaction. See here. You will write here male, then female, then you write here job satisfaction. Then what else? With payment, right? So you go and you draw this matrix. How to do it? This one is represent the male. This one represent the female. This is the coefficient. Because if you go to up, you will find this one is CD. Here. This one. 175. This one for the summation coefficient of male, this one for female. And this one is negative, for this one is positive. So now, if you go to this matrix, you will write like this. You will take, for male is 3.504. Yes. 3.504. 5043, right?
Yeah.
For female, the first one here, 3.6629, right?
3.669.
For the second one, 3.8825. 3.8825. For female, 3.903. 3.903. Then the last one is 4.639. 4.639. Here, that's it. 4.384. 4.384. So this is the matrix, right? Then you go to here, insert, you just make it like this. You go to insert, you select from here this one. So this is now how to draw the interaction. You see here, this one, the male, right? This one is female. In terms of job satisfaction, the male is negative, the female is positive. Here is in terms of payment is opposite, but in terms of the overall interaction they are equal. Both of them are significant. Okay, so this is how to draw the effect of the moderator. Okay, here just you can write. Gender, moderate the relationship, okay? So this is the way how to draw your moderating. Okay? So that's very simple, right?
Yeah.
But you need to get the software to be very easy for you, because it is just within a moment you get the whole result. If you do it manual, it will take long time. You know, first what you will do if you do it manual, you have to find the standardized of the data. You have to transform the data. You will do like this. You go to analyze, then you go for descriptive, then here descriptive. You just key job satisfaction and payment. This one you can turn back. Then you just here say set standardized. Okay. Then also here you say gender here. Then make okay. See now if you go to check your data, you will find you have new variables in your data. This one 3 variables. See this one. You check here. See the new variables. What you will do now? You will run direct relationship, and then after that you will type this is the gender, this one times this one, then the result you will run another regression on the job satisfaction, then it will show you the interaction. There is many steps, but in using this software we give you the whole result without making any change of your data. Okay. If you want to do it manual, this one we can do it. Just you do like this. We go to analyze, then we have to type transform, compute, then you have to do like this. You can write interaction here, int. Interaction, then you just directly make this one. You make here gender time payment, this one times this one. Okay? So the interaction. Then you make okay. So now we create another variable, which is here, the interaction. So now you run the regression. Analyze, regression, linear. So you make job satisfaction as a dependent variable, then this one as independent, then you include the interaction one here. You include first the gender, where is it? Here, and then you include this one also. So now we run it. the result. This is the result we found. See here. This is the by main. It is significant, right? Gender is not significant, and the interaction is significant. The same what we have found there. But the system is already do it for you. You don't need to do anything by yourself. Okay? You see here the estimation coefficient here in the previous one. This is the estimation coefficient. It's exactly the same. What is it? Here. This one, you see, this one is significant. Significant. This one is what? 9.8. Just memorize this one. 984. This one went 160. Right? See what we found here. What we found here. Here. This one. Who went 985 and who went 16. We found the same result. Based on this, the interaction we can compare whether there is a positive or negative. But this one, it doesn't show you whether male or female is the more moderate the relationship between the dependent and independent variables. But from using this software, it will give you all the details. And also it can give you the matrix, how to draw the matrix of this relationship. This one is clear?
Yeah.
Because most of you, when you do research, they ask you to include moderating or mediating, right? So you have to know how to do it. If you want to do it just manual, just very simple. You go and transform the data of your dependent and independent variables as well as the moderator. You have to create the standardized data. Then after that, you time the gender with the independent variables. Then you create new variables. We call it the interaction. Then you run just normal regression. Then you will find this result. Or if you don't like to do all this progress, you download the software, the one we download now. Then you run it just only with a direct relationship. Then it will give you the interaction, all this. You understand this one? Or we repeat it?
Repeat that.
Okay. You want to repeat with the software or with this one?
Okay.
Software, right?
Yeah.
Okay, you go for software here. We go for, because first of all you need to download the software. After you download the software, you will find it's already here, regression, and this is the software we download. This function is not existing in SPSS. When you download, you will find it directly here. So now we click on this one instead of to click on linear. In normal situation, we click on linear, right? But here, we click on the process, what do they call it? Process B3. So here we click on this one. For this one, now it's almost ready. I mean, everything is ready, just you need to key the variable. This one is Y variables, which means the dependent. X variable, which means the independent. Then here mediator, when we want to test mediator. This one is moderator, when we want to test the moderator. Then you key here the moderator. But here we have 92 models. You need to select only the one is related to mediator. See, you have here 92 models. So for the moderating, you select one. For mediator, you select 4. Okay? So now we want to test the mediating. We click on one, that means we select mediating. And when you select here one, mediating, you have to key your moderator variable here, not here. This one only for mediator, right? Here one for moderator. So you just key it here. Then you go to the option, you select for mediator, you select the generate code, and then mean central for construction. Then you say continue, then okay. So then it will give you the result now. Oh, but we forget one thing, sorry. Analyze, integration, process. Here, this one, the bootstraps should be 5,000. Okay, you have to make it 5,000. Sometimes by default 5,000, but sometimes it's less. Then, but you have to make it 5,000 bootstraps. But now the result is, there is no issue. Why we need to make the bootstraps here? To find the significant label. You remember when we do it manual, first we transform the data to standardized, right? Then we run the model. Here, when you make the bootstraps, it's already makes standardized for the data. It makes simulation for the new data. So then you just say okay, then you will find the result. Just wait, because when you make bootstraps, it takes time. So now this is the result. This is summary of your model, dependent, independent, moderator. Here, number of observation or number of case, 250 respondent. Then the model summary, this is the R square. Then this is what you are looking for, estimation coefficient. And the most important is what for you, the interaction. This interaction is confirmed whether there is this variable play as a moderator or not. Yes.
The 250 we identified there, is it for the parent side or the gender?
No, this one, the overall.
Okay.
The overall, male and female.
Okay, so the 250 refers to the moderating variable. Why I'm saying this is, for instance, I may have respondents who feel the gender, but they did not feel, maybe I didn't have enough data, there were missing data in the parent feedback.
Okay, but yeah, here because there is no missing data, all variables have 250 observation.
If I have missing data in any of them, which one would be used in this analysis?
This one, actually, I never try with missing data, but usually they will give you maybe for dependent and independent, not for moderator. Yeah. And here just they give you only the estimation coefficient for gender. So this one is clear?
Yeah. Need more exercise. So.
Yeah, just you need to try. But there is, very simple. You got the independent, then what you are looking is only for the interaction, this one. Because see, here you have direct, right? This is the direct, gender. It's not significant. So now, we are looking for the indirect. The interaction between gender and payment, then the effect on job satisfaction. Okay? So the indirect, or we call it the interaction, is represent the effect of moderator. If it is significant, then we compare moderator, or sorry, the gender, moderate the relationship between payment and job satisfaction.
Here it is not significant. Yeah, it's significant.
Significant here. The interaction is significant.
Less than 50%.
But the direct one is not significant.
Yes.
So that means the confirm is full mediator. Sometimes this one is significant and this one is significant, which means it is partial moderator. Because there is full mediator and partial mediator. But because here it's not significant, but the interaction is significant, this means it is a full mediator. Clear?
Now gender is the full mediator, right?
Yes. So we go for the mediating, right? So for mediating is the same. What you will do, mediating is and see also moderator can be categorical variable, can be also continuous variable. When it is continuous variable, you have to segregate your data. You have to segregate your data to two symbol size. How to segregate the data is just very simple. Let's say we consider now the justice as a moderator, not gender. So how to solve this problem? You have to create two data. You have to create new variables, but with two label of data. You will go to here, transfer. You go for record into different variables. Let's say now our moderator is continuous variable, not necessary nominal or categorical. Maybe we can consider or we can assume the supervision is a moderator. Okay? So then we put it here. Supervision as moderator. Right? So then you have to segregate the data into two files. How to segregate it? Just you go to here. Transfer, compute, here, transfer, then record into different variables. So you go to this one. This is the variables. What we call it, supervision, right? Here. So name of the new variables, just we can say super M, okay? Then here, change, here. This one. If you see the data of this variable for supervision, this one, right? Here. What is it? Okay, let me just see the data. The data, we can check it from here. This is the supervision, right? Let me just, this one don't make anymore. This one, the data of supervision. You remember where we said in the data, the Likert scale, we have from 1 to 5. From 1 to 5. So we can consider from 3, 1 bar. From 4 to 5, 1 bar. Here we call it low, this one high. This answer of the respondent, when they said disagree, strongly disagree, strongly disagree, disagree, natural. Natural means also not agree, right? So then we can consider this one the low value, this one the highest value. So then we segregate our data based on this low and high. So what you will do, you can just go to transform here. Here, transform. We set record into different model, different variables. We go to the variables. So we write the name of the new variables, SPSS. Then we go to change the values. Here. Let's say we say less than, or we can just select here range. Okay? From 1 to 3.
Low.
Yes. The value here, just we can consider it 1. Because we are going to, instead of we have 4 data, then we make it only 1 and 2. Like, for example, when we have male and female, right? We said male is 1, female 2, right? Here also the same. The low we give it 1, high we give it 2. Okay? So now we transform the data. That's what you will do. You will make the range from 1 to 3. We give it 1. Then we make add. See now?
Low.
Yes. From 1 to 3 is
Low.
given low and the data will transform, will only consider one. Then the second is from
4 and 5.
4 to 5.
yeah, here. Just make okay, here just make more than 3. More okay, let's just say here range, you can say just 3.01 to 5. Okay, this one just make here add 3.01 to 5. Here you make 2. Now make okay. So now from 1 to 3 will be 1. From 3 and above will be 5. Sorry, will be 2. So that means we segregate the data into 2 categories. From 1 and 2. This is the idea. This is when your variable is continuous variable. You need to segregate the data, create like 2 groups. Because moderator should be categorical. Then we make continue, right? Continue. Now we go to our data. Oh, here. Just try. Okay. If we go to the file now, we have new variable. See this one. We have only 1 and 2, right? This is our model now. We don't have now anymore this figure. See how the figure transform here. This one it was 3.10. Then because it is more than 0.3, right?
Yeah.
More than 3, then it become 2. Those who is less than 3, this one less than 3 become 1. So now I create new data, and this data it has only 2 categories, 1 and 2. This is the idea. So now I run it. I run the moderator variable, the new one, this one. So the name of this one is SUBM. So I go to just here. General, regrade analyze, regression. Then we go to not linear here.
Yeah, so
You can use linear, but I told you have to do it manual.
yeah.
Yeah. Then you just do this one. Here our dependent variable is job satisfaction. Our independent variable is what? We can select by mint, no problem. But for our moderator here, we have to select this one. See, even become categorical automatically by itself. So then we include it here. Then we go to this one option. We select the first one and the second and the last. Then continue. Then okay. Now it will give us the result. See now this is dependent, independent, and then the moderator, right? Yes. And now we see the effect, the interaction. First here, this one is direct has significant. Supervision direct has significant. Interaction not significant. So that means what? This variable is not moderator. Okay? So this is what you conclude. You can conclude that the supervision is not moderate the relationship between payment and job satisfaction. This one, if the variable is what? Continuous variable. You have to segregate the data. This is the most important. You have to learn. Okay, change. Okay. There is something wrong with it. Okay. We'll do it next time. Huh? So now it's clear. Moderating is clear. How to run it. Now we'll go for mediating. The idea of mediating is different. Moderating is just only moderate the relationship, right? Moderate the relationship. That means there is a relationship before. But now for mediating, that means mediating that there is no relationship between A and B. And the relationship should be in this way. It should be like this. This one should be in between. This one is only like this here and mediate the relationship. But this one should be in between. Or you can draw it here. You can just make it here. This one the mediating. The mediating variable.
Mediating means if there is no issue between the payment and job, right? Then
Okay?
to do the mediating effect,
Yes.
when you don't have any effect, direct effect on the job and the payment, right?
Yes. Mediating, like for example, let's say you want to do this workshop, but there is no class. So then the workshop cannot be run unless there is a class. So this mediating should be there, should be available. Otherwise,
Without mediator, there's no.
there is you can do it, but I mean you will face difficulties. But when the class is available, then easy to communicate between the vendor and individual.
Mediating is the solution.
Yes, but moderate is no. Moderate only to affect the relationship. For example, you can study statistics in the class, but if there is a workshop, it will increase your understanding, right? So that's it works as a moderator. Yeah. Okay, so now we go for mediating. What you will do now for mediating? Just very simple. You just do analyze. You go for regression. Then we have already the software. Just reflect this one process. So here, let's assume that this one works as a moderator. The payment. Sorry, what was here? Yeah, supervision, right? Yes. Supervision was as a moderator, as a mediator, not moderator. Now we just put it here. But this one, the data is not correct, the one here. We have to use the original data, which is this one. Supervision, right? This one, moderator. So then this one, you just throw it back. Here you need to select model number 4. Yes. Select model number 4. Then from here, from option, you select this one, and this one. I mean this one. First one, I think you can keep all. Then click continue. Then okay, then here just make okay. Now you will see the result. Now this is the summary of the model. Model number 4, right? For mediating. Model number 4. Then here we have job satisfaction by man, then moderator. Then after that, you have to check the result. But here what you will do, you have to check whether this one full mediating or partial mediating. So now this is the relationship. Here we have job satisfaction. This one is what is here? We have the payment, right? Then here we have the supervision. So this one is like this. Okay. So now see here. This one is what? Supervision, right? The dependent variable. The independent is what? Payment. So this is the coefficient. And this one the significant level. So then this one it will be when payment on supervision when for 2.6, right? And this one is significant, right? Then we make like 3 stars here. Then the second one, supervision on job satisfaction. Here our dependent variable is job satisfaction. Our independent variables, payment and supervision. So for payment, this is the coefficient. Payment to job satisfaction. When 5, 9, 5, 7, 9. 5, 7, 9, 5. Right? It's significant, right? Here now, supervision to job satisfaction. This one, supervision to job satisfaction. When 276, right? 276, 0. You check the significant level is significant. So now this one is significant. Okay? So to test the effect of mediating, you need to find the indirect relationship. This one all the direct. We need to find the indirect. Then we can decide whether this will play as a moderator or not. So the indirect effect you need to find it from here. This one, you have here total, direct here, you have indirect. And this is the coefficient of indirect. And the degree of significance we can determine from this interval, from low and high interval. If you see here, how much is one? 12, right? This is the indirect. Just make it like this. Okay? The indirect. How much is the situation coefficient?
Situation coefficient
12, right? 12 to 1, right?
Yes.
To determine the significant level, you have to check here. If this one crosses the 0, then it's not significant. If it's not crossing the 0, that means it is significant. How to determine it's crossing or not? Because this is the relationship. For example, here negative, this one is the positive. And in between is 0, right? The numbers from negative to positive should be, there is a 0 in between, right? Like here, values less than 0. This one, the value is more than 0. You see here, the interval is not crossing the 0. This one is the 0. Now, how much we have here? The value 2.05, right? Which means here. Which means here. 2.05. Something. 5.9, right? And then the highest value is 18, which is here. 0.18. So the 0 is existing between those values? No, right? The value is out of the range. It's not crossing the 0. The 0 is not crossing between this and this. It's out of the range. So that means this coefficient is significant. Here is significant. If this one is, if the 0 is in between, this one is not significant. Okay? So now we want to compare. When we say significant, that means this one is moderator. Now we compare with the moderator, but it is full mediator or partial mediator. How to determine whether it is full or partial mediator? You have to check the direct relationship. If the direct is significant and this one is significant, then we consider it as a partial. If the direct is not significant but the indirect significant, then we consider it as a full mediator. If this one not significant, then we consider there is no mediator. Just very simple. Two things, right? If the direct significant and the indirect also significant, then we say partial. If the direct not significant but the indirect significant, we call it full mediator. Yes. So it's clear? So that's what we have in this workshop. Do you have any question in mediating or anything? So you need to use this, download it in your computer, then it will be easy for you to run mediating and moderator.
Sir, in our regular classes, did you teach this topic?
No. Because in regular class, not enough time. Right?
So if you have time.
But that's why we do workshop.
Yeah.
To cover everything. That's why you need to attend workshop as well as the class. If you lost one, then
So
you
if you repeat in the class, it will help for us.
okay, no problem, we will do it.
Because today we just get the basic, right? Class
Yeah,
will
actually
practice.
statistics, statistics, you cannot learn it within one class. Statistics, you attend, you learn, go back and practice it. Without practicing, you will not understand anything. In the slide, I just write all the steps for you. You go and practice it. I give you the data and the slide and the steps. So what you need more than this? Just go and work on it, then you will learn, you will be expert by yourself. Then next class, next workshop, you can run it by yourself. The data with you, slide with you, so steps already there, and with the big chart, how to run it. Then we try to make you expert in statistics.
So this process we cannot do mediating and moderation.
No, there is such way, but it's a little bit complicated. But this one it's already ready. You don't need to get any headache. You just use this one, download it, then you run it. When you download it, you just check this one, analyze, regression, then you go to linear, here, you will find it here. From regression, okay? From regression, then you will find it here. So any more question? Yeah.
For the missing data. So when we have to use the mean and when we have to keep them empty.
We said if the missing data, the total number of missing data is less than 5%, we replace with the mean. If it is more than 5, you keep it empty. You keep the missing data.
Even if the percentage is so high, for example, more than 10%.
Yeah, because if you replace with mean with more than 10%, that means you run again the data, you will get different mean. So that means your data is you already create data by yourself.
If you keep them empty, this will affect our results.
No, it will not affect, because the result will take based on the mean. They will calculate based on the mean of the data that is available there. Not based on, this is the advantage of statistics. Statistics, for example, now in this data, when we check, for example, the mean for male and female, we have in the data 241, I think. 218. And for female, we have only 69, I think. But when you check the mean, you will find almost the same.
But some authors,
not because of the number, because of the mean. They take the average.
some authors said if the missing data is more than 10%, in this case you should delete that.
You can delete or you can go and check collect data again. And you can delete them, collect data, replace them. But you know, sometimes if you delete them, sometimes you will face problem in data collection. Your symbol adequacy will not be enough.
Is not enough.
So then you have to keep it. Otherwise, the system won't, the result of promo test will show you that your model, your symbol size is not enough.
So what should be the standard small size? Maybe standard.
For what?
Standard small sample size.
It
That's
depends
one.
on the.
That's
maybe
one based on how many questions you have in your how many questionnaire in your items.
Okay.
In your how many items
Maybe
in your
10
questionnaire.
to 15 question.
No, if you have let's say 10, then time 10. It will be 100.
Okay.
Not research question, survey question, survey questionnaires. How many items? Like here, see. Here. This one, let's say here how many? I have 5, right? Then we have here 11. The total will be. I have here
46
total 45. 45 times 10. I'm supposed to have 450 respondents. 450 respondents. I distribute to the people. I have to collect 450 respondents. Some researchers they say times 5.
Yeah.
But best, yeah, I mean there is
on the population.
Yes, there is different way how to calculate the sample size, and also
Yeah.
when you know the population and also when unknown population, there is also different method. We are going to learn this one in our class. Yes. But tomorrow we will have class for SPSS. Sorry, AMOS.
AMOS.
No, AMOS.
When to use the primary data and secondary data, if it is up to you to use, or if it is on topic, you have to use.
This one based on your research. Sometimes your research, you cannot investigate it using primary data. You need to use secondary data. Sometimes also you need to use secondary, not primary, based on the objective, the research of objective of your study. For example, if you want to study something related to the financial market, and you want to measure the performance of the company, you cannot just make interview, or you need to, you cannot do a survey. You need to evaluate the performance based on the financial report. But if you want to measure the behavior of the behavior of the employees, or behavior of, the perception of the investors, then you can do survey. And based on the objective of your study. Yeah. Any more question? No.
Not for today.
But sorry, for tomorrow, you have to bring your laptop and you have to bring AMOS with you. And if you don't have, there is one shop there. I think you have, right? AMOS.
Can we download from the internet?
They can download. Okay, then tomorrow you just bring your laptop, because those computers doesn't have AMOS.
So can we download from the net?
No, you cannot down online. This one you need to get the crack of the software. Before you have, right? Not now, I mean tomorrow morning. So then you don't have any question?
Okay, thank you very much. Tomorrow we will to continue. Assalamu alaikum. Thanks for the cooperation. Tomorrow, as we know, we will commence as planned. But we have been told some people may need the video. We will send the link to you so that you will be able to access it after the program, number one. So tomorrow you may bring your email addresses. I think it's not in the form. Was it provided? Yeah. Okay, then we'll get it from there. Or we just send you the link and you can check on your phone
our YouTube address, then you can download the video show.
Yeah. Okay. Okay, thank you very much.
Thank you.
See you inshallah tomorrow.